Hello everybody, tonight we're back and it's the 31st of July, Monday the 31st. Hope everybody's had a nice Monday. So far with us today we have Patricia UK, Frankie UK and Chris from Canada. Hi guys.
Hi Gareth.
Hello.
Hi everyone.
Cool. Oh, it seems to be stuck on me, which I don't like. There you go, that's better. So how's it all going today? What's everybody done today? We had quite a long hangout last night, didn't we?
I was catching up
Yeah,
on
we
it
did.
this morning. It was quite interesting because I couldn't stay for long last night, but I caught up this morning and yes, it was very good. Very, very good.
Yeah, I've had some very positive feedback from that hangout last night, Chris, on the YouTube page.
That's good. Any particular questions, queries, or anything to follow up on? I'm still doing more research on it today too.
Hang on, I could look in the chat room. I got to turn this off because I can't do both. Sideways. Everybody's just saying good evening at the moment. They're a few minutes behind. So you've been doing some more research then, Chris?
Yeah, I've been. I'll share the screen here in a second once I get it set up again.
Okay, then. Shall I just present you then?
Sure, if you like.
I'm presenting you. Be able to just put your page on now.
Let's switch it to a screen share so you don't check out my beard so much.
Everybody in the chat room, so Chris is just getting ready to put something up for us to see, so it'll just take a couple of minutes and then I'm saying goodbye. I'm saying hello to everybody in the chat room. Coming up, Stan. Oh, Stan! Oh, Stan.
Let's try it this way here if I can.
Christy, just bear with us, everybody, while Chris does this.
So I just brought up an article here. It's actually from 2012, but there's still articles, newer ones in this. And when I checked Wikipedia, this one's about, it's in the Siberian Times, but it's about a crater. It's called the Patamovsky crater in the, I can't say it's Russian, but Irkutsk region. And there's a whole write-up on this particular crater. And you can kind of see in the first picture there, it's more of a mound than it is a crater. It's quite a large one when viewed from the air. And I thought it was really interesting because it's got basically a huge crater of limestone rubble. And you can see it's probably 100 or more feet high because these are trees, right? Full-grown trees. So it's a couple hundred feet high. And it's got this perfect raised dome in the middle with this pile of rubble around it. And so I started comparing that to some other pictures here. So this search, just so you can see how I'm kind of doing it, I just went electric universe, geology, arc strike as keywords, and brought up some similar pictures of formations, because there was a few questions where people were asking where some of them are raised rather than the hole, and some of them are raised up. And that has to do with the polarity change. And this picture here is a good example. So these were laboratory experiments done by Dr. C.J. Ransom. And what he did is he took various powders of different elements, like, some were lime powder, and some were talc, and some were, clay and dirt and metal and everything else. And then he just zapped them with electric charges. And you can see that, especially the first 3 or 4 there, look exactly like that crater does. So you have the ring on the outside and then the raised dome in the middle. and it creates a perfect crater. It looks exactly like that one in Russia right here. And then I saw that I checked out the what the stone actually was. It's a limestone, so it's a dielectric. It's not like iron, so it's a negative type of ionization that happened here. And it pulled all this stone right out of the ground and then fractured it in a single spot. So then what I did is looked at it in a little more detail. There's some interesting things that I noticed in this article when I read through it. One is that of course, they think it was the main theory. What they think caused it, they're still saying, oh, it was part of a Tunguska meteoroid that exploded over the Tunguska region, but there was never any meteoroids found. Like they never found any evidence of an actual meteor remains in either location in 1908. But this one here was dated about 400 years before that, when they took cores of the trees. And there's some trees there's no trees that grow on top of the crater, but there's trees around the base of it. And they found some of the trees were, I think, 480 years old, according to the article, roughly. But the interesting part about the trees is that the trees that started growing initially after the strike grew at a rate twice as fast as the surrounding trees, and further away from the strike. They grew twice as fast as any other tree in that region. For the first 40 years of their life, their growth rings were twice as large as anything else in that area. So I thought that tied well in with Ken Wheeler's done some work on that too, where he put plants in a negative field and plants in a positive field, like magnets underneath the plants. One was positive, one was negative, and the plant that's negative grew twice as fast as the one that was positive. So I think that's probably the reason why the trees grew so fast after the strike. So it's a fascinating little article. And then to kind of back it up with what we were talking about before, other than just the shape of it, I went to this is the Wikipedia article on it. And so it seems that it's interesting because when science, mainstream science, fails to come up with a logical explanation, they first to say it's a meteor, but then they can't prove it's a meteor. They come up with a theory that it was some sort of a UFO that was shaped like a cylinder. So they think that there was a UFO that was a cylinder that hit the ground and then went into the ground and kind of vanished because it was more dense and it sunk into the ground, left this mound of rock behind it. So they think there's a UFO underneath it, right? So they default to the UFO theory,
which they want to do, don't they? Which they want to do. They'll want to take you there. And takes you away from it.
If they find these, takes you away from the truth, right? But they don't want to say, oh, it was an electric strike, right? And then I'm going to switch screens here because I want to show you how I kind of know that it was electric and the proof that it was electric. I'm going to switch and share this other screen here real quick, if I can.
The dreaded change, Chris.
Yeah, got to get it down to a science. So I'm just going to jump back to the Google Earth ball thing again because it's the quickest way to show this to people. Okay, so I went to Google.
You like using it. It's just that it's the easiest way to show things on a Hangout, isn't it? When you've got all these windows open and stuff. Anyway, carry on, Chris.
Yeah, if I had a real map that had all the detail on it and all the layers you could zoom right into the crater, I would use that for sure. This one's not very accurate when you're trying to measure degrees. It doesn't work. So there's a crater on Google Earth, and you can see it from the top on the pin. So naturally I go, okay, so if this is one of the poles, there's got to be another pole that matches it in basic size, shape, and it can't be that far away within reason. And this is a fairly small crater, so this is quite localized. So it's not it's a secondary hit, right? This happened within the last 500 or 600 years, so it's pretty small, really, when you think about it. But it still has a matching negative. When you go over to this side, and I found the opposite pole, and the opposite pole is a perfect spherical lake. It's been filled in with water, and it looks like a negative. Now this one's interesting because I think it's actually a double negative. I haven't really seen that many of those, which is why this one, like
What's
this
a double negative then? What,
well,
two?
because this one, yeah, this one here is like, so this is definitely had negative. It looks like it had negative polarity because there's no iron in it, so there's no positive magnetic materials really, because limestone's kind of a dielectric. It's not really, it's diamagnetic. It's not, overly magnetic. It's not like ferrous iron or magnetite or anything of that type of iron ore type of material. So it's more like salt, right? It's more like limestone's more like a salt dielectric. And that's why it has this, it doesn't have those features. It has more of a rounded feature. So it's probably almost deep underground, and there might be pockets where this is kind of semi-hollow. More like probably what the moon's made out of. And then this one here is also negative, right? But it matches it in size and scale, and it's about 6 kilometers away, and it's the closest strike to that area. But it's also negative, so which is interesting because it's when you try to put the electrics together. If you had an imbalance, like an imbalance or it's out of phase, like an imbalance in charge, then it's still arced out. So you would have had a negative field that arced out to another negative field, but one was stronger than the other, and it made a circuit temporarily. Yeah, which is I find that part kind of fascinating because most of the ones that we look at, you'll find a positive pole with the iron, and then a negative pole somewhere handy that's not iron. It's something more dielectric, like lime or basalt rock.
Is that quite a close strike? Because sometimes they're miles apart, aren't they? That's
yeah, 6 kilometers is pretty close and pretty small. And like I said, this isn't an epicenter of a more larger mega strike. I think this one happened quite recently, which caused me to believe, like we were saying, that the really, really big ones that caused all the cataclysms in the past and ripped up the cities and threw down the balls and all that stuff we've been looking at. This one is a lot smaller, so this is within the last 500 or 600 years.
That's a man-made one with them playing and testing and seeing what they can do, or do you think it's more a natural one?
No, I think it's still natural. It's these once the region is hit once, so you can see that in the past there was a really large one that happened a long time ago, and once it's charged, if you look at what they call, it's not a magnet, it's I think they call them electrics, I think is how you spell it. But you can charge, like if you take a nylon ring or a nylon washer or something that's a nylon and apply a static charge to it, even just something small like a cap off of a water bottle, and you apply a high voltage charge to it, the charge can last for weeks. It'll stay charged, and it'll stay charged in the kilovolt range, like 10,000 volts and you'll get a shock from it, like a little zap off it, right? But it's high voltage, low amperage. And I think this is what happens here too, is once the first strike hits, it kind of charges that. We get the rapid growth of trees and grass and water comes to the surface, and it takes, so as the regrowth happens, the trees are consuming the charge. So over, hundreds, thousands of years, the charge just starts to kind of come down. And then, so the next strike that hit, it was just a small one, just a little tiny one, because it didn't have as much charge on the ground. Because really the ground could only bring down roughly what it has in it to make contact with what's above, because the two charges kind of have to balance in phase to make the connection. So I thought that one was
You found a
kind of
new one, you
fascinating.
mean? Yeah, because you found a new one.
Yeah. Yeah, I like it when I find these new ones. Like I haven't seen this one before, and I like it when they make the news because people like, oh well, Tunguska Crater's a famous one.
Just
This one's
changing the
obviously
subject a tiny bit, Chris. I was just wondering what you thought about all these sinkholes that are appearing everywhere, especially in Russia.
they're a little bit different process. I don't think they're doing a lot of fracking in Russia, like as far as the natural gas, but we get them in Canada too, in the north. And what happens, I think, with those is you get underground pockets of natural gas and methane under the ground in bubbles under the ground, and then what happens is it provides a differential of charge potential. So coming up through the ground, it creates kind of a vortex, and it just warms the permafrost that's above, like because in Canada, I'm sure Russia's Siberia is about the same altitude, same latitude. So you get about
Can I tell you something
4 to
I
8
found
feet.
really, really strange? When you get to places like Lithuania and even into Russia, even if they have really cold winters, they have really warm summers. They're hotter than us, and yet they're norther.
Yeah,
They're
they do
more
have.
north.
Yeah, they're short and they're hot. Yeah, yeah.
Because I was a bit surprised to see holiday destinations there. I thought, oh, you wouldn't want to go, but they do. They all go to the beach. It's 30, 40 degrees. You think, how can that be when they're more north and you sort of associate Russia with more colder weather? So there you go.
Yeah, it's a short season, but it can still get pretty blistering hot. Canada's the same way up north. I mean, you get summertime in Canada pushing 35, 35 degrees up north. It only lasts for 3 or 4 weeks, but it's hot, yeah, for sure.
It's just, I think what it is that because there is no North Pole and South Pole like they say, but if people just realise, like you've got Everest in a really hot country, but the mountains have got snow on them. The Alps are the same. France is quite hot. Then you've got the Alps, which is really cold, and then you've got Italy after it. But like, and Spain. But like for those bits, it's really cold. But there's warm land one side of it and warmer land the other side. So it's the same thing, isn't it? It's just they've decided to call it the North Pole, haven't they?
Yeah. Yeah. Once you get into the electric side of it and start studying it from a perspective of electromagnetism, like a dynamo, and so the negative, wherever there's a negative charge tends to be colder, and wherever there's a positive charge will be the hot zones. So I think our weather is not. It definitely doesn't follow the globe model where it's high pressure zones and then it rises up and it cools and it flows. I mean, there is some natural convection and thermal dynamics involved as heat rises. I mean, that's pretty simple stuff. But the basic driver of it is actually reversed, right? When the electrics, say from the sun, makes connection with the positives in the ground, well, it's actually the ground that's heating, right? More so probably than what the sun is emitting as photons. Because if you think about it logically, like the sun can come down on a snowpack mountain or snowpack even in the wintertime. The sun can blaze down on that for a day and only melt it maybe an inch into the snowpack, and then you'll end up, even in the summertime, the sun only penetrates the ground. Like in Canada, we have permafrost. They call it permafrost for a reason, right? It's permanently frozen. And the sun only penetrates, in some places, 2-3 feet. And that's as deep as the radiation from the sun actually gets. So the heat is actually coming from the ground up, right? As it tries to meet with the electrics in the sun. So it seems to be reversed in a lot of cases. I think the majority of the heat comes from the earth itself, right? That's part of an electric circuit. So people want to focus on understanding how all this works, and just look for fulgurates from electric arcs, and you'll see pictures that look like this. I mean, even modern day lightning strikes. When I see stuff like this, I instantly think, well, there's the Siberian mountains and Grand Canyon and all the lakes, rivers, especially the ones that flow north, right? They flow opposite of the equator. which also debunks the globe completely, right? Because in theory, a spinning ball, there shouldn't be any rivers and lakes that flow away from the equator. They all should flow respectively towards the equator just because of centrifugal force. This here is just where a modern day lightning strike hit a chunk of concrete like on a sidewalk, right? Can make connection with the rebar on the sidewalk and blast.
Today, sorry, just say hello, Series is joined us. Hello, Series.
Hello.
Series.
No, my internet was apparently dropped out.
Oh no. Okay then. Anyway, hello, Series. Are these things being made today, Chris?
Yeah, this one here is fairly recent, from what I gather. Like this one here is on the beach. So people take pictures of these things all the time. This is actually where a lightning strike.
We're looking at the map. Are
Sand,
you
I mean.
showing something else? Are you showing something else,
Okay, here, I'll
Chris?
go back out of that. Yeah, I got to do that again then. Stop sharing. I'll jump into something else here. Well, let me know. I mean, I might switch talking on a topic and not have the pictures to match. Keep me in line for sure.
That's it. You're there now.
All right. Yeah, so this is where, someone in their travels, the lightning hit the beach. It's not a jellyfish. It's actually glass.
It looks like one. Yeah.
It looks like a jellyfish, yeah. Well, and then now you start to see, okay, well, this is what's interesting about it, is the jellyfish are formed based on, really basic electric distribution.
Yeah.
Their actual body shape takes on the most natural shape for the environment that they're in, and which makes sense, right? If you're in water and you're a buoyant jellyfish object made of single cellular with no skeletal anything, if your body grew in a fashion that was balanced with the electric phase of the water that you're in, then you can move around more efficiently. So kind of one leads to the other. So, it's interesting. So I find it fascinating that, the lightning hits the sand, which is full of salt and water, and it makes like a jellyfish out of glass, right? Just two and two go together. And here's one that, this is another one, Nemo's.
The fourth or the third?
That one actually might be an actual living creature. I'm trying to look for the ones that are actually lightning strikes that look like living creatures. They're really cool. If you find them, you'll find lots of them. Like here's one that was a lightning strike. So what happened was the lightning hit the ground first, made the fulgurate out of the sand, and fused it into a sculpture type of thing. Looks like a sand sculpture, but this is actually a fused sand that was fused by lightning. Right. And then it just
That's quite yeah. Is that just sand then?
Yeah, it's sand that was hit by lightning recently. So the lightning hit the sand and pulled the sand up and then fused it into this sculpture. And people take pictures of them all the time, right? Fulgurate sand.
Wow.
Some of them are quite huge, eh?
Yeah. Look at that one.
Yeah. I like this one because it actually bends over back on itself. Looks like a snake or whatever coming out of the ground.
Yeah, dragons out of the ground.
Like dragons, yeah.
Yeah.
That square one in the left bottom of the rose.
This one's I can't read it whether or not it's because it's in Spanish, but this one might be someone trying to make it because there's a bucket laying there. I'm not sure, so wasn't sure if that was someone made that one or if it was actually found that way. I don't know. But this one's definitely a fulgurate. Yeah, maybe I don't know. I can't read it. Maybe if anybody my Spanish isn't that good.
Mine neither.
Yeah.
Very interesting though. I don't think I've seen those before.
The coral is actually a slow version of lightning, it seems.
But yeah, exactly right. If you go back and look at some of these pictures, that's kind of where I was headed with it too. Is sometimes they'll actually take these and polish them up. So here's, if it'll actually bring the picture up. So that's what this is. It's basically lightning that hit must have been some really pure sand with nothing but silica in it. And it captured the lightning in the glass. And then someone's taken it, obviously, and they put the machine to make sculpture out of it. And you can see how closely that matches coral. Like Sirius just said, coral is essentially the same dielectric charge process. As coral grows, it follows the same pattern that electricity does. So, roots in trees, the way trees. There's some pictures here, I think, on this other one, maybe where it was. If I find the right one. There's a cool picture of someone caught lightning hitting a tree. That was a great picture.
Which one are you showing us, Chris? All of them. Oh, I see you're picking a picture.
I'm trying to find the page that it was on because I got several pages open here.
Do you think there's a connection here, or it's just coincidence and they look alike then?
Oh, I think it's 100% connection. Yeah.
You do? Oh, wow.
Yeah, 100%. Oh, yeah. Just the natural process, like the way trees grow, they follow electric charge distribution. So the roots in trees, flowers, everything follows the same electric patterns. And I think once we figure them out, you figure out how the charge distributes itself based on its chemistry, right? The bonds in the hydrogen atoms, they tend to form different shapes. Can't find the
Cool.
true
Just
one
when
yet,
you think
which
there's nothing
cool.
else to learn, there's more to learn.
Always more to learn, yeah. Yeah, so this is partly the interesting ones, right? So it depends on the charge, right? So you can see that in this area there was a positive charge, and the area was pulled
you're
up.
showing loads of pictures, Chris. I don't know if you need to change the picture again. Sorry.
Yeah, it's updated.
Maybe take a second to catch it up here. Yeah, so the second picture from the left on the top there, where my little hand is pointing, the positive charge makes the peaks, and then sometimes the positive charge, as it makes the peaks, will dig a line down the center of the peaks, and then it fills in with water. So that's how you end up with areas like the Grand Canyon, where the plains that are outside of it are lower than the Grand Canyon, but yet where the river runs down the middle ends up being deeper than everything. So first it raises
Chris, I'm not
up.
sure if the chat room can see it. I can just see your icon in the chat room.
Here, I'll stop sharing and redo it.
Oh, that's it. No, it's okay. It's okay. It's there. It's there. So sorry. It's just, it was an icon, and sorry.
It's an update.
That's all right. That's all right. I'll go back here. Yeah, I'll go back to this one. Yeah, these are pretty small pictures. I didn't zoom in on them or take them down to bring them up as examples. But there, so you can see that as the electricity travels, right, it digs out and then it makes veins off the side like roots on a tree. But first it digs out and then the water comes in after. Which is why, like I was saying, you get places like the Grand Canyon where the plains are lower, and then there's a raised region going into the canyon, and then the canyon is actually in the center of the highest point, but it's deeper than everything else because it's first the land raises up in the electric field, and then the charge digs into the center of the vein where the electric path is the shortest, and then pulls everything else out. And I'll just look up the Grand Canyon because there's some interesting shots I wanted to show you of that too. But Grand Canyon here. What images? You know, this place comes under debate once in a while too. I can find a good picture here.
It's interesting that Angel last night said that, you know, the Grand Canyon was made in minutes again, like you thought it had been.
Yeah, I agree. It happened in mere minutes.
Yeah, you can see here all the peaks, all the little peaks below.
Yeah, so these peaks here they're not identical, but they are very like these tower ones, especially like they're freestanding towers type of idea. So this is almost identical, not exactly identical because it's different type of rock, but it's similar. I mean, it's sandstone and granites and different types of minerals. But generally speaking, this type of a tower setup is the same as what we saw in Cappadocia, right? So the electricity came in and just removed everything else and left these ones as freestanding stabilized zones. So as the electricity enters the ground, it stabilizes it because it gives it force and charge around a column. Then everything else gets disrupted and gets blown out of the ground and sucked up into the air. And some of the characteristics of the canyon that's probably a painting.
Yeah, these grooves.
Bring up some good pictures of it.
Oh, look at those colours in there.
So 100 meters deep or something.
Oh yeah, it's huge. I'm trying to find a good picture that really shows the debris fields here, but maybe this one will. This one looks okay. I'll let this one update for. Right. So the common theory is that there were lakes to the north, and you know, basically after the ice age or whatever, the lakes were full, and then it busted open and came down and washed all this out. But I do have a bit of an issue with that because there's no evidence of any water erosion anywhere in the canyon except for where the water flows still to this day within the first couple hundred feet where the river flows. And it's lower now than it was, but I think the water line is, you know, within a couple hundred feet of the bottom, depending on where you're at in the canyon. But you can see how vast the canyon is and all the terraces. So each terrace is essentially a distribution of charge potential. So you can count it as, you know, there was this much energy, then this much energy, and that was taken out in one fell swoop based on the charge. And then you can see how there's a peak and then there's a pile of debris, right? So this is all smashed up rock on top of the layer below. And then this layer here is again covered with debris from the one that was above. So as it was pulled out, the debris fell back down and then filled in the layers. Right? Because it's not like these have been collapsing, you know, down and down and down and down. I'm sure they probably do to some extent, but not to this degree where even the most high layers have debris on top of them. So the highest is still covered in smaller rocks, a lot of it, like just millions and millions and millions of pounds of stone on the top. The very high peak.
I suppose I never really looked at it like that before. But you always look at everything differently now, don't you? Now you realise that it's not what it's supposed to be, or there's something else to it.
Yeah. Well, you see how it was tore out in sheer squares. Like it was actually, then these little angular spots is actually smaller rocks and debris. So it is big chunks of iron and magnetite that came from somewhere else.
Oh, you mean they've been dumped there?
A good way to look at it.
That's been dumped there, you mean? It wasn't there and it came through all these strikes.
Yeah, it seems also you could have several
Right.
working
At the same time.
Yeah.
Yeah, so the center of the arc force, so imagine the biggest lightning bolt you can think of, came ripping down through the center and tore everything up and out, blew everything all apart, but it brought it, as it tore it up, it made these sheer cliffs, which would be square, and then these angled parts on the shelves that are filled in, so all this is loose material that's been filled in after, so it was dumped in from the top down and then fell back down in, and then the water came in after and washed out. So it's actually reverse of what you think it is, because even the highest peaks, like way up here on the top, have all these small rocks and stones on the top. On the very highest one, it's still covered in debris, like all the way up to the top. And each one of these layers is coated in debris.
Interesting.
So it's the reverse of what you think it is. Yeah. And the rocks that are on the top are the more iron-rich dolomite stones, and they're the ones that were the hottest. So they went up into the air, were heated, and then fell back down as a different form of rock. In some cases, like this is red sandstone, and then all the heavier iron rocks, rich rocks, are on the top. So it was completely flipped upside down.
Yeah.
But the scale is the problem, right? People, it's hard to get your head around the scale of what happened. All right, the sheer scale of it just blows your mind.
Yeah.
There's lots of peaks in the Grand Canyon that are similar to Devil's Tower too, like these freestanding types of peaks and valleys. But you can see how it looks like a debris field, right? So it looks like you went in there with a mining operation and dug it out, right? And then the rubble is from the mining operation, right? It does look like that. I mean, if you compare that picture to a modern mine, well, it's pretty close. It would look pretty close. But there's no circular gouging. It's all square-faced. So it was actually just tore out and then dumped back on top of itself.
Just like the lightning.
Like a lightning strike, yeah. And what's interesting is that you can see the different colors. So you have a base of sandstone, more like sandstone and red iron oxides. And then so that was pulled up and out. And the stuff that fell back down is more gray and more of a dielectric material. I don't know exactly what it is because I haven't gone there and actually tested it.
Chris, what do you think about the pyramids they think are there then? People say
I don't know, I haven't seen them. I haven't seen them. That'd be more for Angel, but I haven't seen the pyramids that are there, whether they're natural or if they're naturally formed and people dug into them for shelter. I don't know.
Yeah, older cities.
There are some cliffs here, though, and I do know that there are cliffs in the Grand Canyon that are considered sacred cliffs that are built by and there's actually caves in the sides of the mountains that were remains of there, similar to what we saw in Cappadocia, and they say they're built, I think, is something. I don't know the exact legend, but let's just do Cliff Caves, Grand Canyon, Cliff Caves, and see if we can find it. Grand Canyon.
I think you might have to represent again, Chris. I think your icon's showing in the chat room.
Okay.
I don't know if they saw that, to be honest.
Here.
That's really annoying. You've got to do that every time.
Yeah, it seems when I change the tab, it kicks me out of the presented.
I think you'll have to explain that a bit again because I don't think the chat room saw any of that.
I'm not sure.
No one said anything, but I just can only see your icon.
All right, so here we go back to. I just want to show you. I'll show you the caves, and then I can go back and talk about the other again.
Okay.
So this, if you want to search for this, people can do this themselves as well. So just go Grand Canyon Cliff Caves, and you'll come up with all kinds of images of caves that are in the Grand Canyon area. And there's many of them that are inaccessible. Like some of these have paths going in, so they were occupied later. but some of them are so high that you can't even get to them. So there's legends that they were built by sky people, that type of thing, right?
Yeah.
But they're way, 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 way up. These ones are actually in Nepal. So there's thousands of man-made caves, 155 feet from the ground, lie hidden within the. You don't see this guy trying to climb to it with a block and tackle, right? He's trying to mountain climber trying to get to them to see what's in them. Yeah. So that kind of tells you that, well, there was an entrance at some point that was on top, and then they built into the mountain, and then, you know, into the ground. It would have been a flat plain probably when they dug in and built their cities, and then it was ripped up and left part of it behind. And now there's no entrance to get into them anymore because it was taken away with the blast. Right. So these are the ancient caves in Nepal.
Amazing.
And this is like, yeah, so the Grand Canyon is one area, Nepal is another area. There's lots of them. Where's these ones here? Mountain cave.
Are they like the other ones where there's no steps up to them, but it's all up there and you can't get to it?
Exactly.
You have to go like
there's,
them.
There's no. Yeah, you pretty much either go in there with a mountain climbing or you go in there with a helicopter, right? There's no way to get to it.
Oh, but it looks like that's been cut. That picture at the top looks like it's been covered in sort of silt.
Yeah.
Whoa. And like that stuff's been found in that cave then?
Yeah, you kind of have to, when you're going through it, you know, use a little bit of discernment and say, okay, well, which ones were there before the cataclysm, were built after? Because some of them, you know, people came back into those areas because that's where the water would have ran, and then they built underneath. There's a few places where they actually built underneath the overhangs, so it was blowing out, and then they took shang and built little cities and little towns underneath the cliffs, you know, trying to hide essentially from the weather. It would have been devastating. Because there's some you can see where these ones I find even harder to explain. I have no idea.
Catacombs.
Yeah, I don't know whether these ones were, because you can see the evidence of where the heat melted the rock and fused it, but then it appears to look like more modern architecture.
I would say that in Turkey they used to bury people in catacombs, and
So like,
if you go to
yeah.
certain places like I can't think what it's called now. I know what it says, but I can't say it. But anyway, this town, you could see the catacombs, but what it is they're supposed to be pointing over the sea.
Right.
Well, the spirits can go over the sea and off, whatever. So, or water in these places, because some of them aren't looking at sea at all, but they would have put them there for the bodies to go in, for the sea to go off to the sea. It has to have the sea by it.
Right. And that's what this could very well be, and I would probably lean more to that because there's no logical sense as far as, you know, access in or out and angles, and it just makes no logical sense other than this may have been an area where it was struck and then a lot of people died, and then they went back to the remaining mountains that still had evidence of being burned by the plasma, and then kind of carved them out and buried the dead back into what was left behind.
Oh, they look, in a sense, even though they're built or they're in a mountain, they look sort of more modern, don't they? Like buildings that we have today.
Yeah, this is more of a Italian Roman architecture style, but you know, I've heard some theories where, you know, it's petrified wood, but I can't get my head around that either. But I think they're burial chambers, to be honest. They at one time buried the people that survived, or didn't survive, I should say.
Looks like it's been covered in something, doesn't it?
Yeah, that's definitely evidence of rapid heating in the cracks, right? So you get a crack, and then the heating is where it's black, and then you can kind of see where they carved out, and made the, I would assume, put bodies in. Yeah, because the windows, you can see that this one looks like a window, but it's not a window. It's just an imitation window. It's actually solid, right? So there's nothing in behind it. There's only one place to put something, and this window is just an imitation. Same with these ones here. They're imitation windows, and then there's a single entrance. So it looks like they build a house for the person in honor of the person, an imitation house of maybe what their house looked like or something, and then put them in it as a burial. Sarcophagus type of thing. These ones here are just, well, let's kind of, hopefully it'll come into better resolution. But you can see how high these caves are. It looks like anthills. So these are 3 guys standing on the bottom here. And if you just kind of do a quick estimate, so you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 3 times 6 is 270, 300 feet to the top. If you just take 6-foot man times, count them up, right? And you can count the layers. So each one of these is an actual elevation of a city. So you're talking 10 stories deep or more, right?
Wow.
And you can see how when the electricity came down from above, it was swirling. It actually carved circular. So that's a circular arc, right? It just kind of drilled through it in a swirling wind and just took it all out of the ground and left part of it behind. Because some of them look like, there's only a partial room. You can see that this one here is, if I was to actually save that and zoom in on it, you'll see that it's not even a complete room anymore. Like this one here looks like it's got 1 door in and 2 partials. There's no way to get into it anymore. And they're everywhere, even on the sides. Now we've actually gone, where's this one here? This is 55 cave paintings. This is more in Nepal. And I like this stuff because you never learn about it in school. Nobody ever tell you that.
Yeah, I think the last thing they wanted us to really know that we used to live in, like, I don't know what you call it, in underground in these big cities.
Yeah. I suspect we were hiding out the Ice Age, and that's, like I was saying the other night, there's only 2 reasons I could think why that many people would go underground. There's one is to hide from the cold, or the other is to hide from a heat or a plasma storm or some sort of natural threat that would drive that many people underground. But at least to go that far underground, right? I mean, it's naturally efficient. I mean, if you dig a house underground, then you don't need any heat anymore. You don't need any electricity anymore. You don't need anything. You need some light, right? But you don't need anything else. Like we build on top of the ground now, and we end up spending thousands of dollars a year, trying to keep it warm. It's because we're exposed to the air. But if you go 6 or 10 feet underground, well, then you're 72 degrees year round for nothing, right? You're just going to dig down a little bit and bury it. And there's a lot of people that are starting to do that now too, with earth homes and stuff.
Yeah. Nice. It would be nice.
It's always not knowing what it was like before, though, isn't it?
Yeah.
I mean, you think that those could be burial things as well, and that the water used to be there? Just asking.
These particular ones, no, I don't think so. Since they're in Nepal, they're so high up, way. Nepal is like Tibet, some of the highest places on Earth. Yeah.
Yeah, they don't tell you any of that in the school books like that, do they? They'll get into all that. That'd be really interesting if we'd done that. I'd have really liked that.
Yeah, me too.
Series.
Yeah, yeah. actual education to live a life.
Yeah. You'll find a lot of this stuff in your region too, Karen. In the Highlands of Scotland, there's a lot of really black stone. It's like a fulgurite glass stone in the Highlands in England and Scotland. Anywhere in the British Isles.
Well, when we were talking last night about the pyramids and that, what did it show? When I showed you that video, I sent you the link. It said underground. What was it? Built, not what do you call it, walkways and things going from Scotland down to
Oh, that's right.
Italy, wherever it was.
All the way into Syria and Turkey, all the way to Turkey.
Yeah. It's like,
so you could actually walk. You could actually walk underground all the way from England to Turkey and stay underground the entire way. Yeah. Yeah.
It's just like we're just not taught any of that. Do you really think it was because of the cold or hot that they did go below ground or built? I mean, those buildings, those windows and that, and the last one, they were out in the open. They weren't underground, were they? Oh, right, I know why you said, because when you're in rock or stone and things, it has a certain temperature which they can keep to.
Yeah, well, before the storm,
right?
Before the storm, they were certainly underground. Yeah, and they were exposed. The storm actually exposed them. Yeah. Like if you think of like the tunnels that go from Scotland to Turkey. So if you imagine there's 1 million people underground, and then the storm comes down through the center of it and removes half of it, well, then you end up all these it looks like partially finished caves and caverns and tunnels going to nowhere, and stairs and things left elevated in the air, and now you're standing in the hole looking up, right? So when we look at these caves, we're standing in the hole that was created by the storm, looking up where we were, right?
It's hard to imagine that what you're looking at takes minutes to do.
Yeah.
It'd have just been utter devastation, wouldn't it? I mean, what we would have said utter devastation in our minds, because that's what we've been told is nuclear bombs. It would have looked like what we think we've been told. One of those had gone off.
Yeah,
that's real.
Yeah, well, worse. Yeah, it would have made a nuclear bomb look like a firecracker. Right? Really.
And again, you think that's when it lets the water in, isn't it? And that I really didn't think about that. Like, I think someone asked a question in the chat room about why these places like this, the Sahara Desert or things like that, maybe they were oceans. And then you showed us that when this arcing happened, the water flooded in and went all across Africa, and this is where there's sand everywhere.
Yeah, and if you imagine it kind of in reverse, right? If you take the Sahara Desert area and some of the Sudan and all that, imagine it at the time of the storm, could very well have been a very lush green plain and fertile ground. The storm came through, and because it was positively charged, tore up everything that was magnetic, like anything magnetic, iron, anything. And the only thing that was left behind was the stuff that was non-magnetic, which is going to be sand, silica, glass, and gypsum and white materials, right? So, and carbon, you'll see some carbon stuff that's non-magnetic. So anything that was positive is gone, and then you're left with a desert in seconds, right? And then the water, because it would have carried the oceans with it as it moved, it would have just brought a tsunami wave in behind it, and that's where the flow, so it flooded in after. So I think the plasma and lightning and all that came through first as a big plasma vortex storm, blew everything apart, left the sand behind, and then the ocean came in behind it in many cases.
What does silicon do in the sand then? Just asking. If sand's got silica, what's black? The black stuff. That's silicon, isn't it? No. What is that?
The black is carbon, and the silica is the clear white glass looking stuff. Silica is like glass, pretty much.
Just saying that because that sand dune that's moving across Denmark. Do you remember I said my friend? and down the road, literally down the road from where this sand, that's got the black stuff in it, which titanium. Titanium do to sand when it's in the sand?
Titanium? Well, titanium is just a standard metal. It's just a regular type of metal.
Sand
Titanium's kind of like
across is full of that titanium. You can see the little grains of it in the sand.
Yeah.
But nobody knows this, that it's the biggest sand, the biggest sand dune in the north, and most people don't even know it's there.
Yeah, there's some strange ones, eh? There's where's that one you're talking about exactly?
Top end of Denmark. Like when you look at Denmark, you don't see it, but right at the top there's like a little finger that sticks out of land. That's probably about 20 miles long, 5-6 miles wide. And that's where my friend lives, right at the top of Denmark, where those two seas meet. And then the North Sea and the East Sea. And then this sand dune is moving across. And in fact, I went the year before last and I went last year and I took a picture side by side. And although the sand dune's still there, you could see how much it had moved from last year, the year before. Anyway, if you're in Denmark, this is one of the places that you'll want to visit. You'll want to go to the sand dunes. You'll want to go to the seas. You'll want to go to Greenland, and you'll want to go to, I've forgotten the other island now. They own, or the sovereignty, they have sovereignty over quite a lot of land, Denmark.
That's cool. Yeah, I'd like to get there one day for sure. There's a few places that are kind of like that. There's if you go online, look for it. It's one's in China. There's a really strange sand dune in the middle of the mountains in China. And then there's another area in Canada that's quite like that too. It's just a huge sand dune right in the middle of nowhere, and it's surrounded obviously by the same type of circular arc strike formation. So it seems that's part of the process too. Sometimes when it hits, it removes everything but the sand. The sand stays behind because it's non-magnetic, or it takes on a different charge.
Yeah, well, the thing is, you look at everything differently now, don't you? I would have just said, oh, look, there's some sand. Now, oh, look, that's in it. Oh, look, they've got stuff about it being magnetical at the bottom, but I couldn't read it because it was in Danish.
Right.
I've got some pictures of it on my phone. I'll send them to you later. Anyway, because this thing's moving across Denmark, the government pay for anybody's houses get lost in it, any farm or any problems, because they can't stop it. And eventually it's going to go over a road, but I mean, quite a bit of time in the future. But yeah, they didn't used to live on that part of Denmark because it was just so sandy. But then they realised that things did grow there, and over time they did move in there because you can only grow so much on it because it's kind of sand based, isn't it? So
I was trying to find some more
okay
pictures.
then.
Carry on. I'm listening. If there's any questions or anything specific in the chat group there, I don't monitor it because I can't do the two at the same time. But
Yeah, I don't know. They're just chatting with each other in the chat room at the moment, saying hello. Some are saying hello, and a couple of people said, "Wow, that's really interesting." When you were talking about, because they don't. If they're going to show you anything, they just don't keep bringing those things up, do they? They'd rather talk about aliens.
well, I would too if I thought they were real. But
They don't, are they? They're using them, aren't they? I mean, we could be the aliens.
I'd say there's probably more odds. There's probably a stronger chance of that than anything else. Yeah. Yeah.
You're alien to this world, at least.
But we almost are, aren't we? Because animals, well, it's not that we don't have that side to us, but it just seems we've completely lost it. Whereas animals know why they're here, the whole thing, and they just live on their senses and the whole thing. And it's a bit like, yeah, we're the odd ones out.
Yeah. You know, that could be too. I mean, I would actually put more belief in the theory that at some point in time, you know, we came in from somewhere else, like we had our own realm and the two collided, or, you know, whatever. I have no idea.
Yeah, the throwback to this realm, maybe.
Yeah, I don't know. We do seem out of place, that's for sure. I know we do share a lot of genetic continuity and DNA with a lot of other things, but I don't know. Like I never really looked at it too much. There is an article.
I just think, imagine someone making a human being. Like, how did someone put us all together then? Because we've obviously been made. Like, everything's been made. It couldn't just appear. Do you think that we all came out of amoebas then?
No, it's the reverse. I'll show you that right now too, because it's something that this is another one that kind of gets on my nerves.
When you know the truth.
Yeah. Or at least
I
something
think really, once you know the truth more, even if we don't know everything, it does get on your nerves a little bit, doesn't it? Because it's just like, oh God, they're still going that way when we need to stop and need to change.
Sweet. Okay, so here, you know how Darwin theory kind of goes something like you start with something smaller, right? Like a bacteria, and eventually you end up with a human, right? And during that process, we were monkeys, right? And it kind of starts small and grows into something more complex, right? Well, when you really look at it, and you look at gene parsimony from an actual, you know, proper perspective is the way to do it. I'll see if I can actually bring up the images here. This is a great article on biology and genetics and stuff. How it actually works. There's some pictures here, hopefully. I thought there's some diagrams. Get through the right picture.
Might just put you on present. There you go, so it doesn't keep jumping.
See if I can view a large image of that, maybe. Can you hear the thunder in the background?
Oh wow, was that thunder?
Yeah. Yeah, so if I lose you, don't worry about it. If the lightning just hit too close and I'm gone.
Oh no.
It might knock out the internet, that's what I'm thinking.
This is supposed to be summer, guys. Are you having hot weather at the moment then, Chris? Or because we're not, it's pleasant, but it's not very warm.
Yeah, we're the same, still waiting for summer to start, so much for global warming, right? We've had a couple of hot days, but otherwise it's been relatively cool for this time of year.
Yeah.
Maybe I'll escape out of that if I go back. Anyway, yeah, if you're really into it, so when you look at the eukaryotic type of developments in DNA and how it's actually the reverse of what Darwin theory would say, right?
Just to let you know, Stan's joined us. Hi, Stan.
Hi.
Hello, my darling. Just let Chris finish this, and then we'll talk to you.
Yeah, no
Yeah,
worries.
anyway, it's a good article.
Thank you,
Anyway, it's
darling.
called. If you just Google, it's a good article. It's called "Turning the Crown Upside Down: Gene Tree Parsimony and the Roots of Eukaryotic Tree of Life." And if you read through it, and this is actually from Oxford University study, but when you read through it, and you may have to read it a couple of times to kind of get exactly what they're saying, because they use a lot of circular type of boggle the mind kind of language. But in essence, what happens is it's the other way around. Like natural systems don't become more complex over time. It's the other way around. Right? Natural systems become less complex and more chaotic. So the more dispersed it becomes, the system becomes less complex. It doesn't grow into a more complex type of structure, right? Because it's kind of dissolving, and that's the way it works. That's just the way everything works in nature when you look at it from the right perspective.
Surely.
Yeah. Anyway, so the whole.
Thank you so much for showing us. You're always really good at getting this stuff up, Chris.
Yeah. Well, you know how you can do that test, right? You take the gene test, and you'll find out if you do the gene test the proper way, you're related to, 30 or 40 races, and you're X% of this and X% of that. So you're a diluted mix of everything that came before you, right? You're not the top of the result of, right? That's because so it really messes with the bloodline theory, right? That I'm related to such and such and such, and I go back the other way. Well, it's actually the reverse. You're a product of 150,000 bloodlines that came before you, right? So it's the reverse. You can't trace your bloodline backwards that way, like the way they do it in a singular. Because I'm related to a king that lived 1,500 years ago, I have royal blood. It's complete nonsense, right? If you look at it from a genetic point of view, it makes absolutely no sense. Because if you say if your two grandparents, right? So your two grandparents are your parents. So your parents had two parents each, so that's 4, right? So now you're a product of 6, right? And the next layer, it's exponential. The next layer, you're a product of 6 squared, so to speak, right? So your genes are a product of everything that came before you, going back as far as you can think.
So it gets harder the more generations there are. So the more generations, the harder it is to ever link back the way you came from, your bloodline, everything.
Right, you're a product. Yeah, exactly. So you're a product of however many generations before, right? Millions of people, right? Because it goes in reverse. It's not singular, right? Because your parents, and because both your parents had 2 parents, and both of their parents had 2 parents, and et cetera, et cetera, et cetera. It's like that commercial that I tell 2 friends, and she told 2 friends, and I'm selling shampoo. Right, within 64 generations, there's 6.5 million people that you're related to, because you're a product of all of them. Right, it's not the other way around, and that's how eukaryotic bacteria and everything else in nature works. It dilutes. Right, you're a dilution or a product of dilution, not a product of evolution going the other way. It's the total reverse in reality. So
oh wow, that's
Darwin was completely, right? I think it's awesome, right? It's because it shows that we're all related, no matter what you do. It's 6 degrees of connection or whatever. And I think it's awesome because, people that say that I have royal blood and I have claim to this and I have claim to that because I'm special, right? That's completely bogus. They have no right to anything else, right? No more so than the next guy or gal, right? Nobody's special, right? You are who you are because
we're all equal, but they can't tell us that, so they have to make everybody other people special when no one is.
Right. Right. I mean, we're all in the same petri dish, and the petri dish is actually being diluted. If you think about it that way, it's all the same petri dish. And with every generation, the gene pool actually breaks down slowly over time, so it becomes diluted. Which is why, if you look at the actual genetics of it, we say we have 20 or 30% of our human DNA is actually used to create a human, and we have 80% of what they call junk DNA that they have no idea what it's used for. But they say, oh well, this little 1% of junk DNA will create a jellyfish, right? And this little piece of junk DNA will create an amoeba bacteria, and this one might create a monkey, right? But it's because it's a product. It's a product of everything that came before it, right? It's not evolution, it's devolution, right? It devolves into something more spread out and less complex. Yeah, it's completely different. Ferrets were shown at the bottom, like if you actually read through this.
So what do you think about? I'm sorry, Stan. We'll get Stan involved in a minute because Stan's going to come and tell us something in a minute about some stuff he's been doing. But what's the difference with the blue and brown eyes or all that? Does that make any difference, do you think?
Well, I don't think so. I mean, it's blue and brown. There's,
you know, that some people get blue eyes, some people get brown eyes. There's nothing to do with your gene pool or anything like that, or you're a certain. You had brown eyes or green eyes. I've got hazel eyes, so I've got green and brown eyes. But I thought I watched one of these. It means different things if you've got blue eyes to brown eyes, but I don't know. You don't think it makes any difference?
I mean, I think certain. I mean, there's certain results. I mean, if you have blue eyes, maybe you're more sensitive to a certain, because light, a different layer of light can penetrate through a brown versus a blue. Maybe you're more sensitive to bright lights or blue light or whatever. But
the chat room now. So Cat's Eye's got green eyes, and Flat Earth Dave has got grey eyes.
Yeah. Yeah, there's nothing.
Well, then what in the chat room? What colours are your eyes?
Other than personally, other than being beautiful, all eyes are beautiful. If you look at eyes, they're all beautiful. And that's what makes each individual special. Everybody has their own unique eye, and it can be traced to you and you alone.
What colour are yours, Chris, for the chat room? What colour eyes have you got? Just asking.
Mine? Oh, mine are brown. I'm a brown type. Yeah.
You're a brown guy. Series?
I'm not sure. Gray, green, a little bit brown. It's a mixture.
Well, Frankie's gone. Patricia, what colour are your eyes?
Mine are blue.
Open. Ja. Die zijn groen-bruin.
Mine are blue.
Brown, yeah. And mine?
Stan, what colour are yours?
Same as yours.
Mine right now?
Hazel.
Yeah,
Brown
hazel.
and Anyway, thank you so much for that, Chris. You're always brilliant at being able to show us stuff. And
namelijk heel
I know you're researching.
Dan is dit onmogelijk.
Siri, you're a bit noisy.
Sorry.
No, we will just looking at each other's eyes.
I'll just turn Siri's down for a minute because Michelle's talking. So, Stan, you've joined us. So what have you been doing, Stan?
It's not so much me, it's the proxy. He's been doing quite a bit. But he's finished the model now of the well, I say finished, it's viewable now in 360 of the eclipse on the 21st. And there's a lot of problems. If I post the link in the Hangout.
Yeah, series will show it, or it's probably better if it's series. And series is on mute. But he's usually the quickest one to doing it.
I saw that when he posted because I subbed to the channel the other day and then got the notification and I looked at it this morning. So I posed a couple of inquiries on his post just to confirm. But
yeah,
it was awesome that he independently came up with exactly the same results that I did. Although mine's not 4D animation, it's a 3-dimensional model where you got to physically move the stuff around and cast the shadows. But yeah, I thought it was awesome. He came up with the same results. I mean, I can't reproduce it either, and to see him animate it, it's just like, yeah, right on.
Yeah, he's proper gone to town on that. It's taken a long time to get that far.
Let me present it, series.
There you go. Yeah, this is great.
Right, I'm just presenting it. There you go.
Still see Chris.
Yeah, we're gonna bring me off.
Oh no, there it goes.
Yeah, it's a little bit slower in the
But yeah, this is what we're seeing from a working model. You know, you've got the sun, the moon, even the moon. We've even put in the scan lines what you're seeing in the sky. You know, it's the moon traveling up and down. It's all everything's as it is. Well, as they tell you, sorry. And yeah, it doesn't work. Shadows bigger, lasts a lot longer as well. It goes the wrong way. And as well, it casts these shadows at the back, but it eclipses the moon on a full moon.
Can I ask you something, guys? I mean, it's not I'm not blaming you either, by the way, but how come we're just noticing this now?
So I don't think anybody's ever really looked into it, have they? Not, you know, everyone just takes their word for it, and when you stop taking someone's word for it, and look into things for yourself, you notice different things. Not what we're told.
Yeah, I agree. The shadow should be going from east to west, not west to east, because I couldn't get it to go any other way myself. Yeah. Unless I put it on a flat plane. If I put it on the flat plane model, and then just do the angles according to a flat plane, it works perfect. Yeah.
Then they said to Jaron the other night, didn't they, that it happens that way because the moon rotates faster. So then in that case, the moon would be traveling backwards across the sky the opposite way for it to happen. How they were explaining it.
Yeah, it doesn't work that way though. No.
No. You got to have what you see in reality. It's got to work on the model.
Right.
And that just clearly isn't. You wouldn't believe the amount of work Z Proxy has put into making it.
And just to explain why, you know, they're trying to say that, like that's their excuse. They're saying, oh well, it's because the moon's traveling faster. But if you think about it in terms of a simple gear, right? The closer you get to the center of a gear, the faster the object moves. So the bigger the arc that the moon would swing, the slower it would go to the Earth, right? The further away it gets, the slower.
It is traveling at a greater speed, but it's not rotating faster, is it? There's, you know, no. It's farther away, so it is going faster in the model, but it's slower than the spin. Because they said every 28 days of rotation on the Earth is one rotation of the moon. But then that's not what they showed in their model. They showed the moon spinning round quicker than the Earth was spinning. Right. So it would have been spinning backwards.
Correct, yeah.
Yeah. Because I just watched it and thought this is total rubbish. And I had to comment. And I just, you know, I commented on Jaron's. Well, it was on Antonio's copy of it. But yeah.
Well, yeah, the other thing too is if you think about it in terms of a year, so the moon is locked into sync with the Earth, right? And it does the 27-day cycle. But both the moon and the Earth in the globe model are locked in with the sun. So both would only move 1 degree per day over a 360-degree ellipse over an entire year, right? So you can't say that now both are traveling so fast relative to the sun that the shadow goes backwards. That fails too, right? Yeah. There's no way they can talk their way out of it.
No, it's only 1 degree of change. That's why he's gone through so much effort to make what he's made, just to prove it does not work. Yeah. You know, there is no arguments with that model. Yeah. That's why we're showing it. If someone says we're doing something wrong, tell us. We'll put it right. You know, this is what we want. Like, you know, any input, criticism, anything. Come and question it. Tell us what we're doing wrong. Because the only way I can see that we can put that right is to flip the Earth upside down, and then everything's spinning backwards anyway.
Backwards, yeah. And he found the same thing I did too. In order to get a shadow that small on the surface of a ball, the scale and the size and bring the moon in a lot closer to the ball object to get a shadow that small to appear. Because if you take a ball near a surface and move it away from the surface, the shadow gets bigger and bigger and bigger until it just diffuses into nothing.
Yeah.
Right? So for
Yeah, he made the shadow right. You know, he pulled the moon closer to make it right.
Yeah, I had to do the same thing. So I mean, that's the only way it works. So you have to bring the moon so close in order to get that shadow that it just blows the lunch anyway. Yeah. There's only one way to make a shadow that small.
Yeah.
So, yeah, I totally agree. That's a great job. Yeah. Hats off. Yeah.
I said to Z Proxy earlier today, though, I said we're going to be gutted if the shadow does go that way, and NASA got it wrong. You know, but I can't see it myself.
It's awful, isn't it? The deception, and they know it doesn't work, and they're still going to put it out and lie to you.
Yeah, that's why we've got to show what Z Proxy's been doing. You know, push it, and all of these we need to show it to everyone and say, come on, answer the questions. How can that be? That's a working model. It's better than anyone in NASA or anything like that's showing us, isn't it? You know, no one else has put that much effort in the mainstream to come up with anything like that.
Who do you go to, though? Who can you go to? I mean, this is what I find really amazing. Like all those observatories, those great big telescopes, when they know the stars are only so many miles away, and they've been telling us about Milky. I'm not saying the Milky Way's not there, but it's not light years away and all that. I mean, who do you go to tell this to? Excuse me.
Well, don't know.
I shared it to my Facebook page this morning. Maybe be a good idea to put some hashtags to it, you know.
Yeah, just I don't do any social media or anything like that.
I suppose we're left to these kind of hangouts and hope that other people think, you know, because it's dispelling what we live on for sure. It's proof that we're not living on the ball.
Yeah, well, people are watching. There's 69 people watching now, so let's just hope there's some, you know, people.
Yeah, share this hangout.
Yeah, share. Go on Z Proxy's channel and share. Oh, it's on Cosmic Surfer's page as well. It'll soon be up on mine. Just go on there, share it everywhere. Say, look, there's problems with this. It don't work.
I always, because Chris knew that it didn't work on his model. You know,
Yeah.
we were going to try and push, you know, get him to talk about it a few times, so to prove to people it can't happen. But obviously, there's that video now.
Well, yeah. What Chris was showing is this is just a bit more in detail, isn't it? But it's exactly the same as what Chris was showing the other day. But this is just like I say, you can put the goggles on with this and sit there and watch it in a virtual world, like how it's meant to play out.
I mean, obviously, I didn't do it, and maybe you didn't do it, but it's just amazing that just an ordinary person can spend time, put it together, and just immediately prove it doesn't work.
Yeah.
It's like, what have we been doing? You know, we're supposed to be in this sort of high technology, and we're going to Mars and all. You know, oh.
It just doesn't work.
Petition.
Yeah. It needs someone though. It needs someone now though to come forward and try and argue it. You know, try and say
Someone big. You mean?
Yeah, look, you've gone wrong here, and then we'll go away and change it, and then come back and then say, well, you know, it's got to depict what's going on above your head. You can't change the rotation of the Earth, the Moon. You can't. That's what we're told, and basically, if you were to put a camera that was on Earth, that would be roughly what you would see above your head, because it does all sort of work apart from the shadows going the wrong way.
But it just seems really incredible that it's not, you know, someone like Chris and this video, you know, they've worked it out, haven't they? Like, how come none of these astrologers work that out then?
They're not paid to. They get a paycheck. We don't get a paycheck. That's the difference.
That's true. It's really bad, isn't it? Just the lies. There's just so many of them, and they just get
You think
worse. Well,
if you go into work and finish your job, you're out of a job. You know, they don't want to be out of a job. They want to keep going into their little tin hut every night and opening their chute and looking at the stars, don't they? Getting paid for it.
I suppose I used to look up and think that they were millions of miles away, but now I look at them and I just think you're only miles away.
Yeah. Well, we all did.
Below. Yeah.
Everyone did. I used to go and sit out on a starry night on the downs and just look at the stars and think, wow, how wrong I was.
You didn't realise they were just there, did you? You didn't realise they were just in front of you.
No.
And the other thing I think that people don't think about much is that when you have this sun in your sky, yeah, we'll just pick a magic 40 miles from where if you had no trees or houses, 40 miles to the east, and then we'll just put 40 miles to the west. It takes hours to go across there, and at the same time, they've got sun in New York and America, while it's taking 14, 16 hours just to do 40 miles over your head.
Yeah, well, I was going to actually try and work out the time that eclipse is taken from the 360 footage the proxy's done. I was going to like work out the rotation and, you know, how long on that video it's saying it's going to take, but it's obviously a lot longer than what it will take. There's just so many problems with it, you know.
Will he come on a hangout then?
I don't know if C Proxy will. He likes to be listening. You know, he's a busy. He is always busy. But what he tells us everything, and like we know what's going on anyway. Like the Cosmic Surfer will probably jump on with me one night and have a chat. But it's all in the video anyway. It's all self-explanatory. It's there. You can't. It's just there. It's a working model.
It's not that a lot of people might not see it on Facebook or YouTube. It's just that it's not mainstream enough, is it, to get other people to take any notice? You know, like it needs to be higher up than that. Unless it gets sent in to a radio station or something, or a television station.
So I have no idea how you're going to do it. I don't know how you're going to wake the masses. They're all zombies. Majority of people are too busy. That's what they're kept too busy to look into it. Aren't they? They have to get up, go to work, come home, walk the dog, feed the kids, wash the house, wash whatever, go to bed, do it all.
Yeah, a lot of people are stuck with small kids, not even thinking about this, not even knowing.
Yeah, eat, sleep, repeat.
Yeah, something like that. Can you stand? I know we talked about it the other day, but there might be some different people in the chat room today. When we were talking to you the other day with your glasses, those goggles, which I fancy a pair of them now. Can you just explain to the chat room what you see with your camera? Because Stan takes, is it you don't move your camera? It's going all the time, time lapsing.
Yeah, it's on now. It's on all the time. It's been on for 6 months. I only stop it to download it, and then I'll just put it straight back on. Rain, shine, whatever. Yeah, it's just on. And they're really good. Everyone should get one, really. They're such good value for money. Forget your P900s, really. They're too expensive and they're junk. You just get a 360
so what
camera.
do you do this on then? What do you do this on, Stan?
A 360 camera.
Right.
If you wait 1 second.
Oh, I see. Right, yeah. I see.
Yeah,
what
wait
you mean
1
now,
second.
yeah.
I'll have to join with my other phone. Hang on 1 second.
Stupid me. He's got the 360 camera. I just thought it was the goggles.
Hello?
Hello. You're going
I'm
to show
back.
us your camera then?
Yeah, well, my other one, I've got two, but I can show you and then you'll see it's not a big deal. It's so easy. Just got to join with my phone, so this might get
How long would it last if you didn't plug it in then, just asking?
about 3 hours.
Right.
I think.
Ooh, bit of echo there. Sorry, chat room. So I'm just going to turn you off for a minute.
Yeah, I don't know what's going on.
I was going to mute you for a minute. Sorry, chat room. Just while Stan's... Oh, we've lost one of Stan. Right. Sorry, you have to unmute yourself, Stan. Whoa, that was a bit of a nasty noise. I'm sorry about that, chat room. Stan, I can't unmute you. You have to unmute yourself.
Yeah, no, hang on one sec. I knew it was going to get a
Ooh,
bit.
that was a bit nasty, wasn't
yeah,
it?
hang on. I'll try it
Sorry,
again.
chat room. Just wait, there's going to be a big noise. I think Stan's going to have a go again. Here he comes. Don't unmute both of them. He's coming. Series. You're muted.
Is that actually sorted?
Oh, there you go. Stan's back now. Yeah, it's not making a noise.
Is it not?
No, you're all right.
Sure, if that was crazy before.
It was, wasn't it? Sorry, guys in the chat room. I couldn't get to the control button to turn it off quick enough there.
I didn't know what one it was even coming from.
Hey, okay, I'm just going to present you now. Just going to present this one.
But this is all it is.
Hey.
Oh, let me move it over there. There's nothing, nothing, everyone can work one of these. There's 3 buttons on it.
Well, how much does one of those cost roughly then?
I paid £150 for this. Second hand on eBay. They're £400 new. But the other one that's on my roof is just a single lens, so it sits like that. That's why you don't get the bottom of the view. You only get the top. Whereas this one, you get a full
360 bubble.
Yeah. But look, there's that's an on button, that's a mode, and then on the top you got record, and it's that simple. And yeah, you can plug it into a power pack, or you can plug it into the mains and just leave it running. This one's actually splash proof, it says, but I've not tested it. But the other one sat in a little waterproof tub. Yeah, when you got the phone and everything, it's just dead simple. And then I've got the VR goggles as well. I'll show you them.
Yeah, they're amazing. And I just want to say hello, Dave. Dave's joined us. Dave Marsh.
Oh, Dave.
Well, that's okay. He's another cameraman. You know Dave Marsh, don't you, Stan?
Yeah, I've watched Dave. So you haven't seen him on there before.
I know that we've already watched it, but in a minute, maybe did Dave see the video of the fake moon clips?
But yeah, everyone needs to get one of these basically. Stick it up on your roof or stick it somewhere where you can see the moon rise and set. And especially them in the eclipse. For the eclipse, waste the time getting a P900 out or anything. Really, this is the key to seeing what the hell's going on. Because you know what you're doing, Dave, with your tracking of Polaris and all your stars and your moon. You hear me, Dave? Muted.
Dave, you're muted.
I'll quit this phone call now. I've shown you him.
I think he's just trying to get his you know, he's just fiddling around.
Straight, there we go.
Oh.
Starting to echo again. I killed it quick.
Oh, thank you, darling. Yeah. Dave, are you there? He's trying, but he's muted. I haven't muted him. I can't unmute. Let me do that. He's trying to come back on. He'll answer you then.
But yeah, no, they're so simple to use, them 360 cameras, and it's the way to track the sky, most definitely. You know, your P900's 500 quid, and that you can buy the single lens one of them brand new for £70. You know?
Having problems. He'll be back. Are you going to say something, Chris?
No, I just watching along there. That's awesome gear. I'd like to get some of that myself sometime.
It's definitely worth the investment. It's a great tool.
Stan, just explain to the chat room. Oh, sorry.
Oh, I was just saying, I'm looking forward to see what Dave's thoughts were too on Z Proxy's video and the moon and the model, and see if he agrees that it's absolutely wrong.
He's back. Are you there, Dave?
Can't hear anything.
We can hear you just about. We can hear you talking. I just wondered, Dave, can you hear us?
Well, can't hear now.
We've got to always have a bit of technical. There's got to be a bit, unless someone's got a problem. I was just wondering if Dave hadn't seen that video, whether the series would play it again.
Yeah.
Play the video again, series.
Okay. Right.
Right, series is going to put that video back up. If Dave hasn't seen it, Dave can see that one again.
Karen B's asking if you can get filters for the cameras for these 360s, and I don't know as if you can, but I did think about making one for the sun so we could track the sun more accurately if we had you know, the glasses you wear, and as you go from inside to outside they react to light, so they go tinted. Do you know what I mean? The optical glasses. If we could get that spray anyway, and make a dome cover to fit it.
So back to the fake fingertips.
Your internet, babes, because I can't even load anything.
I'm going to turn Dave down there for a minute. when you see that, Stan, it kind of annoys you, doesn't it, really, that they've deceived us so badly, and it takes one person to do this, and you can just, there you go, we're definitely not a ball, or there's something definitely wrong with it.
Yeah, I've seen so many things, problems. You can't have one problem. If you've got one problem, that's it. It's the same with the Gleason's map and everything. There's problems, so it doesn't work.
If it's not perfect, then it's not truth.
That's exactly it.
Yeah, I was watching a little bit of Thrive and Survive on the Life of Riley before I came on, and Thrive and Survive was going through the AE map to show you how distorted some of the countries were just to fit that map. Like South America is much bigger than North America, and yet in reality it's the other way around.
Yeah, it's because everything's stretched out in the south, isn't it?
But South America is huge compared to North America.
Yeah, that's what I say. It's all stretched, isn't it? It's all wrong. You only got to look at the lines to see how stretched it is. It's to match time, isn't it? And the sun doesn't move any quicker no matter where you are on the Earth. It's always.
So just to explain to people, Stan, which way is the moon supposed to be going? It's going left. Which way is it supposed to go? If all the information they're telling you, which way is it supposed to go on the globe?
Exactly the opposite to what we're showing you. The shadow is meant to start the opposite side and work its way across the globe, not, you know, not from east to west, but from west to east. That's what they're saying.
Yeah.
So why would they tell us a lie like that? When wouldn't it be much easier for them to have sort of done it so it was going the other way?
Because it's not going to go the other way, is it? That's what they predicted. It's going to travel the wrong way to what you can produce on a globe.
Yeah, because people on the ground, in reality, it is in actual fact going to travel from west to east.
But then what we've been looking at as well, Chris, that the sun and the moon, we don't think are going to be they're going to be in line with each other, so to speak, but there's going to be a space between them. They're not perfectly lined up, so there's something else. There must be something else at play, or something. We're missing something from what we're looking at.
You mean when you look at moon calc and sun calc or whatever, they don't line up quite right? Yeah.
Yeah, we've been looking on Stellarium. And,
Oh yeah.
and there's something we're missing, but we haven't. Like, we've been too busy talking about this all the time to look, But that's why we're pushing for these cameras, because then you'll see exactly where the sun is, and you can track it all with them cameras. If you turn down the exposure on the 360, you can track the sun a lot better. But even a picture at that time from a 360 camera would be of more use than a video review from a P900, just so you get positioning.
Something else too, I was looking pretty hard on the internet for real live footage of solar eclipses, and I couldn't find any, at least not yet.
No.
That showed even a partial moon coming in towards the moon or towards the sun, then causing the eclipse, and then the partial moon going out from the shadow. Like, it seems to me that all you ever see is just the sun go dark. Like, you don't see the moon coming in towards anything in the shadow. Like, there's no crescent on the moon. It's as if there's nothing there, and then all of a sudden there's a shadow, and then it's over. Like, has anyone ever actually seen the moon and the sun in the sky at the same time coming into it? I wonder.
Well, not from what I can see.
Uh,
And that's what I say. It doesn't line up on the time and date.
You'd think, with a little bit, if a couple of filters, even you could be able to filter enough the blue light to see the moon or whatever.
Well, someone out there's got the capability of doing this and pulling it off and showing everything. But whether
Another
they
thing
will or
could
not.
be something else people could check could be the time of the eclipse, and then see when the next time of the moon rise is and where it rises, and see if it actually, according to the globe model, it came back too fast, whatever. Right?
Yeah.
If you have an eclipse in the middle of the afternoon, then the moon rises again at 6 p.m. Well, something's wrong, right? How can I do that? It didn't obviously go around and come back, right?
Just someone's mentioning, I think it's Sandra's asking, what time will it be in the UK? But where will this eclipse happen? Which countries? Just America, or does it go?
It's just America. Yeah, you won't really be able to see much of it, I don't think, from where you're at it. You might see a bit of a dimming, but you won't see the full eclipse. Starts in California and ends up there somewhere. I think. Let me look at the map here. I got a map in my model. Where it ends almost coming on to the coast of Africa. So it crosses from California, starts in the North Pacific, crosses the U.S. on an angle, and ends up in this almost at the equator, South Atlantic.
So,
Jay, are you with us now?
That's where it is. That's where.
Oh, Dave, can you hear us okay now?
Yes, I can now. My computer was playing up. I had to restart it. There was nothing whatsoever, not even on the videos on my hard drive. So I've just done a restart, and it seems a little bit better now, but it's a little bit sluggish. So can you hear me okay?
We can. Dave, you obviously know Chris and Siri's on tonight. And do you know Stan?
No, I don't.
Stan Smith.
no, I've seen you in the hangout before, though, Dave. I've seen you on the show chatting about your tracking and stuff.
Yeah, that's cool. Yeah, I've got some good stuff. What I've been doing, I've been ill over the weekend. I've had a sore throat and what have you, so I've just been taking it easy. But I was actually I've been playing around with moon calc and looking at the moon, what it's doing when it's going from north to south in regards to like the full moon. I've mentioned on a number of occasions that. When you have a full moon in summer, it's always in the opposite hemisphere and vice versa. Well, I was wondering what happens in between that then, as the sun starts getting southern declination, what's the moon doing? So I've just been running a few simulations, and maybe when Chris is finished, I can show you what I've been up to.
Yeah, what we did was Chris had done his own one, but Stan's brought this one in to show. Obviously, both of them are saying the same thing. There's just no way. It just proves the globe's a lie. And then Stan was talking a little bit about he's got a 360 camera.
Yeah, I saw that. I saw it. I couldn't hear it, but obviously I saw him messing about with it, like on the floor. Like, is it for the Samsung Galaxy phone? Is it?
Yeah, that one is. But I've got another one as well. But you should get one, Dave, as well for your moon tracking, because it's so much easier than what you're doing. Like, I can show you a video that shows you all the paths of the moon and everything.
Yeah, I was looking at the Nikon one, because Nikon do one, but it's about 600 quid, and that does 360 as well. And but for the price, I thought it's too much. But I've seen the Samsung one, and like I say, you can just plop them on top of your head, can't you? And
yeah, the Samsung one is a good one, but the other one was only £70 though. So the one that's on my roof and it's been up there for 6 months, it's I think £60 I paid for it. It's been as good as gold.
Cool. I'll have to check that out.
Yeah. Well, there's some videos I can.
Sorry, I was just going to say, you came on the other day. I wanted you just to explain to Dave what you saw in the sky.
I'll show you. I can share a video.
Yeah, sure.
don't know what one's gonna
Dave
be
might
better.
have seen it, but well, I'll just present you.
Oh, I can't share it. I won't be able to.
Oh, do you want to put the link? Can you put the link in the chat room and Series will show it?
See that. If when he puts it on, if he just mutes it and then goes to 1 minute 8.
1 minute 8. Series, are you there?
Which is,
Series. Sorry, Series. I know what it is, guys, is that when Series and Chris aren't talking, they carry on researching in the background and listening.
there's no time like the present. But yeah, Series,
It is now, guys.
if you can shift that like mute the sound and then just shift forward to 1 minute 7, I think it was. And then present it, and then you'll see Dave will see the tracking from my roof. It's only a short clip, but then just pause it again as soon as it goes off. And then we can shoot forward to the next bit of tracking from South Africa, which is at 2 minutes. Yeah, the next bit's at 2:21. But yeah, this here, that's the moon tracking, like what Dave is doing, but obviously I'm doing it with a camera rather than sitting out there all night looking at it.
So what period is that over the? So each white dot, I assume, is the moon. Is that what
Yeah, right. If you pause it, Series. If you go back on that quick and pause it. Right, each white dot, like as it goes along horizontally, basically, like it's in an arc, isn't it? But they're going across. That's the moon's path across the sky. But
How many days is that then?
that is 14 days. So it starts at the top, look, where there's only a few dots because obviously it was a cloudy day and a small moon, so it was harder to track in the daylight. You could only track it at the end of the day, see there. But then as the nights drew out, we could then track it longer. But that's 14 days of tracking there, like one day after another, to show it stepping down. And then
that's from tropic to tropic. Well, close to tropic to tropic.
Yeah, and then what it does is it then just steps back up for 14 days, and then repeats back down, back up, back down, back up. But then if you skip, like if you note though on that one, the red line's at the top, the blue line's at the bottom, then the yellow line's in the centre. The green line there is your horizon. But then if you skip to 2:21 Series, this is because that's my rooftop and that's on the Isle of Wight in England. If you go to the Cape Town one, if you just let it play for a sec.
Series is munching a biscuit, aren't you, Series?
See, right, if you pause it there, like there somewhere.
Series.
No, we've missed it. See, that was only a real short clip. But that one was the South Africa, Cape Town scan lines, like the moon tracking for 14 days. See, this is just one track, and then this is just one night track as well.
Who is that? Is that Cosmic Surfer or is it somebody else?
Yeah, Cosmic Surfer. And then that's my sky again. Look, it's showing the moon how it goes across the sky.
Well, interestingly, I was looking at that because I don't know if you're aware that whenever you have like a full moon, the sun is always in the opposite hemisphere and it changes. And I was interested to know. Obviously, the moon's still got to cover that same distance when it goes from full moon to new moon. So as the sun's getting southern declination, getting closer to the equator, what's the moon doing then? Do you know what I mean? So what I'll do in a bit when you finish this, I'll show you on Mooncalc and Suncalc what the moon's actually doing when it goes south for 14 days and then comes back, because it's interesting, because like I say, it needs to still cover that same distance to keep that 27.3 day cycle. Do you know what I mean? So
yeah, but it is, look, if you look at that, it's not changing distance, it's always staying within them bands, so there's no speed up, speed down. It's you know, it just changes tracks.
Yeah, I understand that, but what I'm trying to say in regards to the full moon,
yeah, I get it, it's always opposite to the sun.
Yeah, and interestingly, like I say, when it's high, when the sun's high on the Tropic of Cancer, the moon's always low on the Tropic of Capricorn, and as the sun gets southern declination, the moon will go back to the Tropic of Capricorn, then it'll come forward to the same position where the sun is, but in the opposite hemisphere. And as it comes further down, move a step closer. So it's like mirroring it till they both meet on the equator. One's just above the equator, one's just below, and then they'll switch. Then the sun will be in the southern hemisphere, and the moon will be in the northern hemisphere on full, and then it'll do that step, and it'll step back up to the completely opposite again for winter.
Yeah.
But that's great, that camera. That's cool, because that's just what I was like filming, really. I'm a moon race video. I don't know if you've seen the moon race video.
Well, I've seen what you've been doing, and that's what I say. What you're doing is like what we're doing, but we're doing the whole sky, and you're taking up a little portion. You know, that's why I say you should get one of these cameras, Dave. Really, you should. You'd love it. You would. It gives so much information. It's unbelievable, man.
Yeah, because what I wanted to do for my next moon race video in September, I wanted to actually. When I did capture the moon on the tropics and on the equator, what I wanted to do a time lapse at that time as well. You know what I mean? At that very moment, you know, in real time. Like last time, what I did, I just took some random ones, like kind of videos from my friends and what have you. But I want to do it in real time. So when I do capture the moon across my screen, and then I can capture the actual time lapse of it.
Yeah. Are you presenting that? You're not presenting that.
Yeah, we were just watching it. I just put it on today because he was talking. There you go.
Yeah. But yeah, basically,
that's cool.
That's what you're seeing, though, Dave, and that's what you're saying about. And then as it goes up towards Polaris, the rings increase. It's like they're just like stacking shelves. Yeah.
And as it gets to that celestial equator, you get that perfectly straight travel line.
But we're not sure if these, you see the lines that are on there, the three, you got the blue, the yellow and the red.
Yeah.
We've been talking, are the lines moving? Are they going up and down? And that's how something's happening, because
due to perspective, do you think, or?
I'm not sure. We're not sure.
You can definitely see the magnification from the perspective of the.
Because if you did that on the equator, surely them lines north and south won't be as bent as much as that. They'd be pretty much straighter, I would have thought.
Oh, they're above your head. It's the same
you know
circle, I mean? But it just travels around you rather than on a 45 around you. You know.
But what I have noticed, if you go to Mooncalc and you go to any day on the moon on the equator, you only ever get like 12 hours. Do you know what I mean? Like because it's like 14 hours or nearly 15 hours in north.
If you look at these lines, how they are led into the ground, you see on the edges how that would be twisted in the ground. One, it's at its blue because this is in the southern hemisphere. One, the sun would be at the top on the blue. You'd have a lot more daylight because it takes a lot longer for it to disappear. See. But then as you're on the equator, you've got that line, that tyre, so to speak, is literally running above your head. So no matter where the moon or sun is on that track, it will always be a 12-hour day because you're seeing half of the sky, so to speak.
Exactly.
So that's why we say like a 24-hour sun in the south is possible, as well as a moon and in the north. You get the 24-hour sun.
Well, if you go to Ushuaia in Argentina on December 21st and look, they get 17 hours of daylight. You know what I mean? And it's the last city furthest south at 54 degrees. So, you know what I mean? It's clearly the further you go south, the more daylight you can see in summertime. But the problem is that place in Argentina is the furthest place south you can go. Do you know what I mean? There's nowhere else further south.
Well, that's what we're told.
Yes, but in the north we can go to is it Franz Joseph and
Greenland.
Svalbard at 79 degrees north, which is obviously a hell of a lot further north than we can go south.
Could I just say that FPV in the chat room said to ask Dan if he's seen any pausing in the moon movement?
No, not really.
No, it's in constant motion.
Yeah, it's just a constant flow. I haven't yet seen the lunar wave either, and I've been out there for some time, you know. I'm not saying it doesn't exist, I'm just saying I've never seen it. I've never seen the moon slow down. It's always, the moon appears to speed up and slow down, but it doesn't. It's only because of the angles you are looking at it. It is just a constant, it's like a clock. It's no different. It's like, you know, it's like the slow hand on the clock. The sun.
The thing is, if you look at the moon from the UK and you time the meridian passing over 2 days when it's on the Tropic of Capricorn, and you time that difference, that gap, when you go to New Zealand from their perspective into the exact same, you get the exact same time. Then what you'll notice on the equator from both locations, when the moon's obviously on the equator, it does actually speed up slightly.
Is that because of the angle they're looking at it?
I don't know, because I'm just collating the data at the moment, and obviously when I did my I only did it from New Zealand and the UK, but I'm getting the exact same readings on the tropics and the equator from both locations from their perspective. You know what I mean? So I went to Mooncalc in New Zealand, and obviously I did the culmination or the meridian passing from their location and the UK, and you're getting the exact same time within a minute of each other. But there is a significant increase when it goes to the equator. For an example, when it was on the Tropic of Cancer on both locations, it was like 24 hours and 52 minutes. Then when it went onto the equator, it was 24 hours 40 minutes. You know what I mean? There is quite a big increase.
Is that because though the tire's above your head and over there you were looking at it when it was on a lower scan, like on a lower line, so to speak? Do you know what I mean?
Exactly, but you'd think though, from my view, looking at it south, with it being further away and thinking about parallax, that you would actually see a slower moon.
I think it's a constant speed though, Dave. I think it's just that it's longer in their sky.
Well, like I say, the data I'm collecting now from I'm doing it from the UK, from Ecuador, and from Ushuaia in Argentina, so I can get, like, you know what I mean, readings from 3 locations. It's a long process, but I'm pretty positive from what I'm saying, that the moon does actually speed up, because, like I say, it's definitely from 3 locations. If you did it just from 1 location, you could say, yeah, it's due to your perspective. But when you go to the other location where it's further away from them, say, you're getting the exact same times between meridian passings.
I think that you'd have to film it from them locations as well, because that's what me, Cosmic, and Z Proxy have been doing with the P900s. Like we zoom in to 83 times zoom, and then we literally put the moon on one side and then let it just track across to the other side. And what we were noticing is when it's at its lunar moon, you know, like this, like for me, it's its southernmost point. When it's at that point and its highest point in the sky, it was slow. It was like it appeared to be slow, but it wasn't. It was the same speed. It's just the angles that you're filming it from and the way it's tracking. You know, that's what it appeared to us. When we compared all the stuff, it didn't. They all matched up. You know.
Like I say, I'm just going by from the data I'm collecting from time of day and mooncalc, and
that's
according
what
to
I'm
them,
saying. It could be because of the tracks in the sky. That's what I'm saying. Though. It could be because we're looking at it out at a angle, and they're looking at it from above, so they see more of it.
But interestingly, this is what put the nail in the coffin for me. So when it leaves the Tropic of Cancer and goes to the equator, it speeds up significantly. But then when it goes from the equator to the Tropic of Capricorn, it slows down. But when it goes from the Tropic of Capricorn back to the equator, it stays at the relative same speed. Now, and then when it goes from the equator back to the Cancer, it stays at relative same speed again. So there is actually a change in speed, because otherwise it'd be consistent both ways. You know what I mean? Do you understand what I'm saying?
Yeah, that's something I have to look at the data and have a look. But from what we're seeing is just what we're showing in the videos. You know, it's then.
Yeah, like I said, to collect this data what I'm collecting, it's very, very time consuming. But like I say, I was surprised when I saw it stayed at the relative speed when it went back from Capricorn to Cancer. It basically stays at the same speed all the way back. But then again, when it comes back to from the Tropic of Cancer to the equator again, it speeds up, then slows down, then relative same speed again. And I'm up to June now, and it's the same pattern all the way through. Interestingly,
that's something you can record though with a 360 camera, and you can prove that that's what's happening.
Yeah, that'd be cool. That, and like I say, it'd be interesting to get somebody in the Southern Hemisphere to actually do these readings. You know what I mean? And see if they can get some similar results. Because, like I say, I'm just doing it from my perspective, which is it's a little bit biased, isn't it? If you've only got me, that's why I've had to rely on the actual culmination or the meridian passing from different locations, and timing that meridian passing between days is the only way I can actually record the speed of the moon. So that's what I'm working on now. But interestingly, I did actually find a working model of the actual lunar cycle from on one of the NASA's web pages from the LRO, is it the Lunar Reconnaissance Orbiter apparently, and it does show you the actual moon phases as it passed through for a year. It shows you the 5-degree inclination, and it also shows you when the moon is closest. And what I did notice when I paused it, the closest on, according to NASA, according to my readings, it's at the furthest away. What they're telling us, if you know what I mean, because on theirs it speeds up as it approaches perigee. Yeah, as its closest approach to Earth. Then once it's past that point, it starts slowing down in its cycle, and then obviously we've been in an ellipse, and it speeds up again. Do you know what I'm saying? But like I said, from what data I'm gathering, it's speeding up as it's leaving towards apogee, as it heads towards the equator. So that's what I'm going to try and put together, because I did try and download it, but for some reason it won't download, and it only just let me play the video. So I need to try and download that video and try and compare it to my readings and see what I've got.
Stan, explain to Dave what you see in the sky, though, when you were telling us the other day, and we were sort of going, wow, about end up and go down, and like what you're seeing in the sky, what you believe it looks like.
The sky's a rainbow. It follows you like a rainbow. You know, just like your moon. But everyone, it's one moon, but everyone just has their moon.
Yeah, it's projected to the actual person, the observer. Yeah, I understand what you're saying. Yeah, it's always projected towards. And what I try to do an analogy is like, you know, when you see a photograph and the eyes face you, and no matter where you move, they always seem to follow you. Yeah. It's similar with the moon.
Like,
yeah, that same.
We used to play a computer game, and it had a what is it called? I can't remember. So well, anyway, this hologram, it always faces you. It's always there, and it's always facing you. No matter where you are and you turn around in the game, there's this thing behind you facing you. And it's the same with the moon. It's always there, just facing you, no matter where you are.
So that bit about when the sun comes to everybody's feet and not the other person's, the moon is the same kind of thing, except it's not doing the same kind of. It's not bright enough.
Everything is.
Everything is.
That whole ball of light up there is your own ball of light.
I do that.
Well, from what you know, unless anyone can say I'm bloody wrong, but from what I'm seeing, you put the goggles on and you look at the footage from a P900, that moon is not, it's no distance away. My P900 has an 83 times zoom. I don't know what anyone else's has got, but really it's junk. You know, you can see with it 20 miles tops, and even that's fuzzy. To see 250,000 miles, you got to be joking. You just won't do it with that camera, you know. You wouldn't even see 100 miles. Well, I don't know. You might see 100 miles, but it ain't going to be clear.
I think the one that gets me the most is when you realise that it is that close, is the daytime moon, when there is some kind of sun shining on it as well, and it lights up and you think, I'm sure I could get to it. I'm not quite a ladder, but you know what I mean. It's like I could get to that.
Yeah,
it's
but you
there.
can't.
No, I know.
When you move, it moves with it, so you'd never get to it.
So what is that, Dave or Chris or Series or Stan? What is it when it all moves?
It's like the gold pot at the end of the rainbow.
Yeah, that's exactly it. That's exactly it.
Interestingly, I showed a mooncalc snapshot of the UK, and it just happened to be that the moon, like on that image, it was over somewhere in France. I think it's somewhere in southern France, and some guy says, so what happens, so the moon will be directly above my head in southern France? I says no, and what I did, I showed him, and I moved the cursor back to there, and the moon moves back a little bit further, you know what I mean? It'll just keep going back with you, kind of thing.
That's what's happening.
Yeah, is that the one where you're saying that the moon goes, like, it goes, the sun or whatever it was, goes, and it goes back on itself and comes back? You can explain that to Stan? Well,
like I say, as you walk towards, as you travel towards the moon, it'll move further and further back to you. You know what I mean? Until there's that crossing point when obviously it'll switch, kind of thing.
I meant that.
But as you get further to the equator, obviously it'll just get higher and higher and higher, and then obviously it'll do that switch, and then it'll go. You'll get the declination, then it'll start dropping and dropping as you move further back.
Yeah, I meant the app he found. You know the app he found with it swinging around.
Oh yeah, that's just mooncalc. That yeah. I'm just trying to get it up now because I wanted to just show you that what I was on about with the moon. I'm just trying to sort it out now.
This could be why the eclipse is only happening over America, because you have to be there for the moon to move, or whatever's moving. You know what I mean? Something's moving. Well, I don't think it is the moon from what we've been looking at.
So what do you think?
So what's your thoughts on that?
Well, I don't know. I'm just saying, like, from what I've looked at, it's, I don't know, you know, doesn't look like it's the moon. That's all I'm saying. I'm not saying it's not, I'm just saying it doesn't look like to me.
So what do you think causes the phases of the moon then, Stan?
I would love to know.
The same thing, it's like the eclipse.
Well, interestingly, I don't think it's anything to do with the declination. I think it's something to do with the east-west movement of it. Because, like I say, when you get a full moon round about the September, March time, when the sun's close to it, you get the same kind of full moon as you get when it's on the furthest away, when it's on the Tropic of Cancer, if you know what I mean. So they're a lot closer together. During the equinox, you know what I mean, the sun and the moon. What I'll do in a sec, I'll if I can you share the screen?
Yeah, sure. Sorry. Go, Dave.
Right, can you see the screen? Yeah.
I can see you.
Let me just try and do this. Think for a sec. So let me just find a date near January. I can't remember where the full moon were in January, so I'll have to just bear with me. Must be somewhere on there. Yeah. So you got the full moon on the 12th, and as you can see, yeah, in winter.
I can only see you.
You have the moon.
I can only see
Can you
you.
hear me, right?
Yeah, we
You
can
know
hear
you
you.
are?
We can't. If you're showing us something, I
Can't you see
can't.
it? That's strange. Can you see now?
No.
No, I can just see you, Dave.
That's weird, isn't it?
Get a bit closer. You can
Maybe-
see something in your glasses. We might be able to see a reflection.
Have to share the whole screen. Chris, what do you have to do then? Because Chris has a problem as well. Like if he changes anything, then he's got to reshare it.
Have you? Shall I come back out of it then?
Yeah, go out and do a full share then. Just make sure you don't put the links up. Well, no, I don't mind if you want the links, but
Yeah, sometimes if I
just
can't
don't
share it,
the Hangout.
I have to share full screen. Yeah.
So if I share,
Yeah.
can you see now?
Yeah, that's it. Oh.
Well, I'm just swapping them around. So I'll just set the sun to the same date. So as you can see, when the moon's high on the Tropic of Cancer, the sun is always opposite on the Tropic of Capricorn, and when you do the other way around, like so it'd be summer, you'll always find that the moon will be always furthest away. But it's quite interestingly, as you go through the full moons. So we'll go to February. I don't know when the full moon is, but somewhere around there. So it looks like it's on February the 10th. Now, if you go to sun cal and go to February the 10th, what you'll see how the angles are getting shorter. Well, it's doing these angles will start getting shorter on the moon. So basically, it's still got to travel for that 14 days to be obviously a full moon from a new moon. But what it'll do to obviously keep traveling that same distance, it'll have to actually reach the Tropic of and then obviously move forward till it gets into the relative position opposite the sun, and you'll find this all the way through the year. Go to March 8th, maybe only 28 days in February, isn't there? So it might be actually. So we're into March now. As you can see, the moon's nearly, not quite there, obviously, because it's about a few days off. To get it perfect to straight line, it'd have to fall. The full would have to fall on the 21st of March, obviously, and that doesn't happen very often. So if you go to February here, March here, what was it, 21st, 12th? So as you can see now, they're exactly opposite again. There's a little slight difference in angle because the moon does move 13 times faster than the sun, so to get it right. But as you can see now, look, you've actually got the sun, which is obviously moving up towards the equinox, and the moon's there. Now, interestingly, when you go to April, April 10th, then you go to SunCalc. You got that switch over. So now they've done a swap, you see. So now the moon is slightly below and the sun is above, and you'll get that, and that will obviously carry on until you get to the opposite ends again. And I just find that quite interesting, really, because even though you have a full moon when you when the sun and moon are furthest away during winter and summer, but when it's round about the equinox time, they're obviously relatively close together, aren't they, on the tropics, if you know what I mean? But we're still getting the exact same phases, and we don't see any difference in luminosity or anything like that, even though they are a hell of a lot closer, clearly, when they're on or around the equator. Do you know what I mean? So that's interesting. So really, that tells me that the phases must be only related to the east-west, to the actual, which is 29.5 days. Nothing, I don't think it has anything to do with that pendulum type swing. I could be wrong, but that's what it looks like to me. It doesn't seem to have any effect of whether the sun and moon are close on the equator or furthest away. You still get that full moon. So that tells me that it's just constantly related to the actual day. I don't know what your thoughts are on that, but that's what my thoughts are. It's just related to the actual solar day.
It's definitely something to look into, man.
Yeah, it's interesting, like I say, because not a lot of people. So in other words, you can never ever have a full moon in the same hemisphere as the sun. It's impossible. It doesn't matter how many years you go through, how many months. There's always that little switch across. You know what I mean?
Mm.
Yeah. So that's interesting in itself, like, and it's interesting that obviously when it is the equinox, that they're all pretty much aligned on the equator, whether it's just above or just below. So that may be something to look into.
So you're up for putting up a 360 then, Dave, and getting some goggles?
Yeah, definitely, mate. Like I say, it's it'll have to be. It won't be till later on this year, like, because I'm not planning on doing anything till September anyway. Because you can't really do many experiments. What I want to do this time of the year, it's a lot better when when you get the waxing moon. Obviously,
longer evenings as well, longer nights.
Yeah, longer nights, like, so. It's a lot better to shoot it with. What you find now is like the sun's out in the daytime when I need it to be in certain positions. You know what I mean? And it's at zenith and all that. And it's just dead difficult. And like I say, I wanted to do time lapses as well, and they don't work very well in the daytime, do they? When you do it like a star trail kind of thing. I've done a couple and they look a bit weird.
Yeah, no, I don't work that well.
Stan did you though, Stan? You bought your 360 cam, one of them you bought second hand, didn't you?
Yeah, I bought one brand new. It was 70 quid. It was only a cheap Panaview one, single lens on eBay, a Chinese one. And then I got the Samsung one that was meant to be about £400. They were retailing, but I got a second hand for £150. There was one on there the other day for £80 it sold for. I was so tempted to buy it, and up to, I don't know what I'd do with two yet, but you never know.
So the blue and yellow and red line shot on that, is that from the software on the camera, is it?
No. All of that has been edited by Z-Proxy. Obviously it's time-lapsed videos, and then we go through the time-lapse videos, take a picture, overlay, take another picture, overlay, and do that for the 14 days. We try and analyze each month, but we break it down into 28 days and then analyze.
Yeah, that's cool. Because Cosmic Surfer, he has some brilliant skies there. Because I was like dead envious. Because every time I see him shooting the moon, it's always crystal clear out there, isn't it?
He winds me up with it all the time, mate.
It's, I honestly, I've never seen the moon as least this year than as far as I can ever remember.
Yeah, I went out there earlier with the camera set up, and it was like, yeah, I can see it. It's gone. And that was it. I just gave up, came back in.
Yeah, there's not worse than you see it. Oh, yeah, by the time you get your equipment, go outside, it's gone again.
Yeah. But yeah, he always winds me up, the surfer does. He's always like, check this out. Beautiful blue sky, not a trail in sight, not even a cloud. Lovely. Yeah.
There's a question from FPV. He wanted to know what time is the eclipse roughly? This eclipse is supposed to be coming up. What time is it roughly?
It's UTC +7, and I think it starts at around about, I'm sure it's about 3 o'clock or something like that. It's on the 21st. Let me just have a look on SunCalc.
I'll tell you what, like these things happening now, more and more people will be watching them now, won't they?
Yeah.
Yeah. Interestingly, there's a lot of videos going out about the eclipse going the shadow going the wrong way. I think to me that eclipse is doing what it should do. Really, the only thing what's wrong on it is the size of the shadow. The shadow should be, for the distances between the sun and the moon and the heliocentric model, that shadow would be absolutely huge. But
it is going the wrong way though, Dave. If you look at the Z proxy model, and he's modelled it all in virtual reality.
Chris has done it as well.
Yeah,
Chris
has done it.
Yeah,
and it does. It goes the wrong way. The only way it can go the right way, if you turn the ball upside down, the Earth, but then everything goes the wrong way apart from the eclipse, or you speed the moon up, but then the moon's travelling across the sky the wrong way.
From what I was looking at it from that point of view, obviously the sun will obviously pass quicker than the moon, so obviously the shadow should enter the right hand side, surely.
Yeah, but you're thinking on your terms. We're thinking what the globe's telling us and what everyone's telling us.
Maybe I'll have to look into that. To be honest, I had a good look into it. I just see it and I thought to myself, well, sure, the only thing I could see wrong at that thing was the actual size of the shadow, because surely something projecting a shadow from that distance, the shadow would be massive, wouldn't it? Surely.
Yeah. You have to bring the moon in closer to make it work.
Yeah, exactly.
we both had to do the same thing to make the shadow work, is to bring the moon really close. Yeah,
sure. I've missed that part of it anyway, and I haven't really been following that, to tell you the truth. So maybe
I had to bring the moon really close, and in the model I did too, and then scale it down somewhat to make the shadow 72 miles across roughly, right? So yeah, the shadow.
It's just another now, isn't it? Just one more now.
Yeah.
See, Proxy's in the chat room, by the way. We've been showing your video.
Yeah, he's been there for quite a while.
Yeah, maybe I'll have a look into that then, because like I say, I've been ill this weekend, so I haven't really done a lot, to tell you the truth.
Yeah, we can run Z Proxy's video again too, but I can show you on the model in a physical sense too, the same problem. If you want to just present it, I can just talk through it real quick.
Yeah, that'd be cool, because like I say, I haven't really had a look at it, to tell you the truth.
There you go, Chris.
So here's the globe. Here's the globe, and I wrapped the map for 100 years around the globe, and this one here, where the shadow starts in the North Pacific, and you can see the date.
I can't see anything.
It's presented. It's on my one.
Is it?
Let me just refresh the chat room to see if it's coming up there. Hang on a sec. Sorry, everybody.
I can reshare it too if you let me know.
I can see it now.
Okay, then, cool.
Okay. I'll try to move it slow so it doesn't, because this is a live refreshing model, right? It has to render everything. So in the bigger picture there, you can see I got the map of the eclipse in that blue line. So there's a shadow on August 21st, 2017. So this path, the eclipse actually starts in the North Pacific, south of Alaska. It makes landfall on California coast around 10 o'clock in the morning. Leaves the East Coast, north of Florida, about 3:17. So it's about a 4-hour trek across. So the speeds kind of work out roughly, right? The speed works out. And then it will finish this path somewhere east of Africa. Yeah, it'd be west of Africa, I guess.
Yeah, because in the UK, you should just catch the. We might be able to just see a little bit of it actually.
A glimpse of a dimming sky. That's about all you're going to see. Yeah. But what you can see is, so if you look at the second screen where I'm rotating the little ball there, so the top one that's like the gray without the rendering, that's the target. So you can see I got the camera pointed at the moon. There's the ball and there's the moon, and you can see how close I had to bring the moon to get that shadow. And if I move that at all,
yeah, I'm going to say that's not 30 Earths away, is it?
I had to bring it in within 10,000 kilometers or something to scale. So if you grab that at all, and if I move it, you'll see that the shadow gets bigger and bigger and bigger. The further away it goes, it just disappears.
Exactly.
So anyway, I'll put it back where it was so you can see the shadow. Just to confirm the setup of the shot here. So I put the camera's approximately, well, the camera's looking dead on the moon. So you can see that I got the moon in the right phase. It is a new moon, so it's like an eclipsed moon, like it's a new moon.
Right.
In order to do a new moon, you have to have the sun approximately, give or take 90 degrees behind the moon to light it up from the back side, so it's black on this side. It's a dark new moon.
Exactly. Yeah.
Right. So then you can see. So those are the first two things. The first thing that doesn't work out is the size. And we know that the Earth, if I rotate it, so here's the problem, right? You have to keep that shadow at a full eclipse. So this is 100% eclipse going the whole way, right? So I can't make any angular changes in the shadow. So here's so if I rotate the moon and the sun and the Earth at the same time, rotate on the Z-axis on the zenith, relative to the sun, you'll see that what happens is the shadow starts to spread because I've changed the angle between the moon and the sun, right? Right, yeah. You see it spreads out now, right? So I lose my focus because I've now changed. I'd have to actually move the sun, the moon, and the Earth all at the same time on the same zenith to maintain a perfect shadow. So that doesn't work. So there's where it fails one time there. I can make it work.
Just my one question. Just my one question. Won't it be from each observer's view? Like obviously, as the moon passes by, each observer will just see will get to see the actual eclipse as they move further down. Just from their unique viewing angle within the red line. Do you know what I'm saying?
Well, if I can show you what happened here, I actually answered that question.
That was my question. Like, surely the reason why the shadow would be is because it's from each unique viewing perspective on that line. That angle they need to be looking at to see the totality kind of thing.
So what happens if I do that? If I take the Earth, the camera, which is you on the ground, and the moon, and rotate it relative to the sun. So we'll keep the sun heliocentric in the middle. And if I rotate you with the Earth and the moon, you'll see that it screws it up too. Because if I rotate you away, keeping you focused on the moon, eventually the moon comes into its phases. See? Right?
Yeah.
So it doesn't work that way either, right? So the only way you can do it is to rotate the ball. Right? Rotate the ball on the zenith. You keep the shadow going.
That's a problem, isn't it? The moon wouldn't rotate that fast in the heliocentric model if it was at the correct distance, would it? If you know what I mean.
No. They say it does move faster, but even if those angles, well, you lose the shadow anyway. That's the first.
That's what I mean. You can't have best of both, can you? If you know what I mean, you can either have one or the other.
Both. No.
Yeah, I understand that. Yeah.
But what I can do is I can make the shadow go the right way that they're saying it's supposed to go, but I have to rotate the Earth backwards, right? And that's the only way it works. I can follow that path precisely, but now I'm rotating the Earth in the wrong direction, right? And that's the only way it works. So as far as I'm concerned, it's impossible to do it any other way. And I'll show you too, just for argument's sake. Let's line it up here. I'll move the moon. Let's move it so that rotate on the Z. I'm going to just line up the shadow dead center in the United States here, roughly on that blue X. I'll spin it around a bit so you can see it. Let it render for a second. To show you the consequences, let's say that the Earth, the moon, and you are all basically stationary, and I rotate the sun relative to you on the ground. And you see you end up with the same problem, right? Because now everything is moving and it starts to spread the angle, and eventually the moon comes into its face, right? The same problem is you end up creating moon phases, right? So if I bring nighttime, because what's supposed to happen is it's supposed to be about 10 o'clock in the morning in the shadow, right? So if I'm moving the sun to the Earth, then it messes it all up again, right?
Yeah.
You end up creating moon phases, right? So it don't work, man. I can't get it to work. That's all I'm saying.
Yeah, it definitely doesn't work because you can't have best of both, can you? Like say, it's either one or the other kind of thing.
Yeah.
It's a strange one. I haven't really looked into it, to tell you the truth. Like only what the videos what I've seen popping up on YouTube and that. So yeah, it's an interesting one. Maybe I'll look a bit more into this, like, because we keep looking at it from the heliocentric model, but there's not many look into it from the flat Earth perspective. I know Antonio Subaras has done quite a little bit on it, hasn't he? So that'd be interesting.
It works fine on the flat model. Like on the flat model, if you keep the sun rotating in like the donut shape we were looking at before, right? And then you do the donut with like what Stan is seeing with the moon, and then you just bring, keep the moon roughly where it is in that position, and then bring the sun up around it over the top. Well, then the angle of the shadow goes west to east, just exactly the way it's supposed to, as the moon passes over top. It works perfect.
Because what I did look at though, because the moon is actually on southern declination or through that, isn't it? So it's heading south, if you know what I mean. I noticed on the shadow it like comes in from the top, then you get totality, and then it goes out like a V shape, isn't it?
Yeah, first it goes. Yeah, it does like a W shape type of deal. It comes in, it drops down, then it goes back to the center, and then it drops again. So for me, that tells me exactly what we're seeing is that there's an angle difference between the sun and the moon, and it's just because they're two different pitches, right? The pitch is changing between the two, and as the arc changes between the two, well, then you get a sine wave, right? That's the way I see it. But you can see I got the model set up here, right? I mean, I got the equators dead on, and then I got the 5-degree inclination, and the sun's out beyond.
And are there other lines on there, the other eclipses we've had throughout the years?
Yeah, if I zoom in on the ball, if I make this a little bit smaller here. So these are all the eclipses for the next 100 years, roughly. It's 100 years on this map. I think there's 100 lines. And the other eclipses that don't work either on the ball model are the ones that travel over the North Pole. The only way to get that shadow in June, like the 2021 eclipse on June 10th, it starts in northern Canada and goes right over Iceland, over Greenland, and then back over into China, right? So it actually doesn't arc across the North top on the ball model. The only way to make that work is to take the moon physically and move it all the way to the top North Pole, and then bring the sun up the other side, right? And have the sun coming down from above, right? So we know that don't work because you can't move the moon out of its 5-degree inclination. So how does that work? Right?
God knows.
So none of these eclipses work, in my opinion. I can't get any of them to work. I've tried, right? None of them works.
Well, I'm sure Z Proxy will have a good go at that one, man. He'd like that one. That sounds interesting.
Will you get to see any of the eclipse?
Yeah, so watch for that one, 2021. Yeah, I'll see a little bit of it. Yeah, it'll darken for for about an hour and a half or something, I'll see a darkness. But it's about 33% or something we see here, because I'm technically on this map. I know Matt and Bradley in the States they're going to see a really good shot of it because it's going right over their heads. So I think Matt and Brad I think is over in the Midwest, and Matt is on the East Coast, and I'm up here. So I get to see the 2024 one. That'll be going right over my head, right? 2024.
Yeah. It's interesting. The shadow looks pretty sharp.
So this one here, yeah.
You know when the actual moon shadow passes over the sun, it looks like it's a sharp shadow. You know what I mean? There's no fuzziness around it at all. So I've looked at a few of the eclipses, and there's no fuzziness around the edge at all. Now you think at them distances, you'd get a little bit of fuzziness, wouldn't you? At least, but it's so sharp. It's like
you would think. And I'll show you in the model too that if I really want to get a really sharp shadow, so I got it set for the sun right now. It's at 100. The strength is 100 illumination, which is like 1,000,000 in reverse. But if I want to make that shadow really, really sharp, I have to change the sun to basically a beam light, like a laser makes it. Like,
it's just gone black, Chris. The screen's just gone black. I
can see okay.
Yeah.
Can you? Yeah. Oh, it's black for me.
On the live thing, on the YouTube, it has gone black.
Yeah.
Chris, represent again.
Yeah, okay. Yeah, so here we go. Back up here a second. So if I change the sun to a hemispherical type of
not there, Chris.
Light, right? Like
it's
a light.
Oh, there it is. I can wait a minute. I might be able to see it now.
Yeah. Yeah. So if I change the light to a hemispherical light, like the same type you'd have it in a lighthouse.
Released your icon showing.
Is it there now?
No, it was just there, sort of, and then I went to present it again, and it's gone. Just your icons there.
Okay, well, I'll stop and I'll reshare again. Just a few clicks away. We'll get there.
What I'll do after this, if you want, I'll read you my letter I sent to the UK Space Agency. It's basically titled "A Concerned Taxpayer Regarding Faking Space," so it's quite interesting.
Yeah. I just want to show you this a little. So this will be quick, just to show you what happens with the shadows, right? So if I set it to the sun, you can see we kind of got a spread out and small shadow. But if I want to make a really, really, really sharp shadow, then I have to change it to a hemispherical light, and then basically move the moon. Right? It still doesn't work. I have to scale the moon down, physically scale it down. I put the cursor to selected. The only way to get that sharp of a shadow on the ground is to scale it down. And as I shrink the moon down in size, relative to a focused light, I can bring it right down to a perfect dot, right? But that only works if you've got this type of the light has to be in a cone.
What about from like Earth perspective? You know when we look at the actual sun, when you look at it, that shadow's pretty sharp passing over that as well, isn't it? You know what I mean? So that tells you that they must be relatively close together for it to obviously have that sharp shadow on the actual sun. Yeah,
exactly. It creates a nice round circle in the sky as well.
Yeah, exactly. There's no fuzziness to it at all. It's really sharp. You know what I mean? Like
it's
two shadows are close together, kind of two objects close together.
Yep. And see, now if you had an arch, so in theory, if you had a ball and it had an atmosphere, which I can turn on, I got the atmosphere on there too, because I tried it. So if I turn the atmosphere on, roughly 400 kilometer thickness with 10% roughly towards the ground, then you can see I can start to see a sun will start to appear here if I angled the camera properly. But it doesn't quite look right if I change it to be like a regular sun. It diffuses a whole lot more. Let's go back.
Can you lay that all out on a flat map, Chris?
Oh yeah, on the flat map I can do it perfect. Yeah.
Well, you can lay all them tracks out on a flat map with that same. Yeah. You can. That's interesting.
Yeah. Oh yeah. Yeah.
That'd be interesting to see.
Because that's actually what this is. This texture overlay is I can show you the file here in a second. Just a second here. I just want to change that back so I don't mess up my model too much here.
Yeah, don't mess nothing up, man.
And I'm going to save it. I'll save that. So you can just say you can just show you that I tried it with atmospherics, without atmospherics. You know, I tried it every which way, and I can't make it work. Yeah, but I can show you I can send you the actual file if you want the map for the lunar eclipses too.
Yeah, somewhere, not just right now.
Yeah.
While Chris is doing that, Stan, interesting. Like I say, if you think about it, when you says like the moon doesn't change its relative speed, it doesn't look pretty good for the azimuth equidistance map projection model, does it? Really?
Right. That's what I say. We need something new. Nothing's working.
Yeah, definitely. It doesn't work on the AA map. Like you can't cast those shadows either properly. You know, it doesn't work. Not that I can tell. But it does.
I think I'd have been a bit upset if you'd managed to make it work though, because then it means the globe would have been right.
No, there's still too many holes in the globe, though, isn't there? Like Polaris, like hardly moving, and like you wouldn't have the same repeated stars night after night after night after night.
Exactly, and also last year when we were capturing Venus at night time, and not just after sunset. I'm talking like 3.5, 4 hours after sunset. How does that work on a globe when it's on the sun side, and the Earth would need to rotate away from the sun for it to be nighttime? So that in itself debunks the heliocentric model. Also, I've got a video here on the was it the July full moon? I caught it just as it risen at about 10 to 9, and I couldn't see the actual sun because from where I am light, but it was clearly daytime, and the moon wasn't actually lit up. It didn't light up till about. It didn't start light up till about 10 past 9. Might show that video because, and also on time and days. I think the moonrise was at 8:40, and the sunset was at 9:15 or something like that. So, you know what I mean? That in itself debunks the heliocentric model. I know they refer to reflection, and I think it's called selenium or something.
Yeah, you see a lot of those days. Yeah, you'll see like a nice bright early morning moon, and it's gone by 9 o'clock, and then it'll reverse it. Yeah, that makes no sense at all on the video for the ball model.
I always like filming with the Cosmic Surfer because where I'm winter and he's summer, vice versa. My sky is usually blue and his is black, or mine's black and his is blue. When we're syncing the moon together, it's crazy.
Yeah, that's crazy, because when you think about it, you're pretty much on the same meridian line, aren't you? It's literally straight down, isn't it? Because I did a couple of moon syncs with Gert from South Africa, and like I say, mine was always in the daytime and his was always in the night, kind of thing.
Yeah, we'll sync the moon, the three of us. We'll stay out there, a lot of the nights syncing the moon. If you look back at our footage, you can see some nights we've filmed together like 10 or more times.
Yeah, I did a moon sync with Robbie Jackson in Tasmania, 10,700 miles away. That's my longest moon sync I've done up to now. I shot it about, I can't remember what time, but I think it was something like 20 to 9 at night, and he shot it at like 7 something the following day in the daytime light. It's on my lunar page anyway, so if you ever get a chance to go on Facebook or...
Yeah, we sync at exactly the same time, we send a message, get the moon.
Yeah, that's
down.
right. That's right with him.
Yeah,
literally. Yeah, the time's exactly the same, but his time's at his time, and my time's at my time, kind of thing.
Yeah,
but we actually shot at the exact
we just
same
go
time.
on UTC, otherwise it gets confusing. Yeah. Some crazy stuff. a lot to be thinking. You know, loads to think about.
Yeah, there is.
Well, that's
Yeah,
pretty.
Too
cool,
much for my little brain.
that is
Guys
pretty
are
cool,
rainbow.
Chris. I like that.
Yeah, just to show you that, you know, so because we're on a public forum here too, that it's not any data that's being doctored or messed around with or anything, because I'm using NASA's actual maps. It's from NASA, so, and I just take them and put them on the ball and then see if it works. So these are the trajectories based on NASA data for the next 100 years. And you can see that they show them going over the poles and stuff and doing all kinds of crazy things, right? So.
See that, like, up until the south, like until you get to the Antarctic, there's sort of patterns there, but then at the bottom there, it's just like, what is that?
I was just looking at that. It looks like one of them dung beetles coming at us.
And it's almost as if that one's like
Couple.
folded in half. Or
Oh, you
something.
see that's exactly what you would expect to happen if you were shining a shadow through a kind of a dome type of lens, wouldn't you think? Maybe, right? Right. It reflects off the bubble, more or less. It's a refraction. Yeah.
So why isn't it happening at the top then? Because there's water up there, or they're not showing you enough to see what's happening up there then? Enough.
Well, there is one happening up the top in there, a total one.
Yeah.
Can they see that in chat? Yeah, they can see that.
Yeah, they should see that. Yeah.
But Z's still there. I wonder what he thinks of that. That is crazy.
Yeah, literally, if you get the International Space Station flight path up, it's very similar to a lot of them through the middle bit and all.
Yeah, it's a wave.
It's like that wave, yeah.
Cosmic
What do
Surfer says it follows the he says there's something about it. It's lost in the like just on the edge of the sun all the time. You know, it's like sort of circling. It's strange how it's.
Yeah, if you look at the eclipse maps, the other thing to take note of, because when I was trying to simulate them, the other thing I had to do was to take note of the ones that actually start to turn backwards on themselves and go back in time. Right, the shadow starts out in one direction and makes a big sweeping arc, and then turns backwards. So you need to think about that too, right? Because how does that work on a spinning globe that's going in one direction, right?
Yeah, you need to send me that picture or something, like just that picture of the map with all the lines and so I can have a look at it. That is crazy.
All you gotta do is just go on Google and search the solar eclipse map and pull the ones that come up from NASA. That's the search I do.
All right. Yeah.
And you can bring down all the maps you want, anyone you want.
Simple as that. Anyone can do it. Like most things we're discovering, Chris.
Yeah, it's NASA's website. Yeah.
Anyone can do it.
Mm-hmm.
Yeah, that's interesting. That some of them patterns.
It's like the bottom's completely wrong, though, isn't it?
Yeah. See, can we? It's impossible for us to confirm that, isn't it? Because if you look at the date, you know, I don't think I'm going to be in 2081. It's
no, but this should be able to make sense. You should be able to make sense of it all.
Yeah, I'm just trying to make sense of it.
That just makes no sense at all, does it? Like the top, like I can see some sort of patterns there, but even they don't all add up, do they? It's not all. That needs a lot of looking at. Yeah. You could stare at that until your eyeballs fall out, I reckon.
And there's another one that Chris is showing a little bit of at the top, like next to the one that looks like it's got the beetle. They're going like round rings there. Look, round rings.
Mm.
Do you see that one just at the top next to the other one?
I can see him, yeah.
It's a round ring down there and a round ring down there.
That's what I mean. In order to do that in the physical realm, it has to change direction, right? The shadow means that the object that's casting the shadow must be changing direction. or else the primary, like the globe, would have to stop and turn around and go backwards.
It could be just because obviously in the north and the south, apparently you get the 24-hour daylight. It's same with the moonlight. Maybe it's you're actually seeing that arc. I don't know.
So what? The red ones are the sun and the blue are the moon, yeah?
No, the red ones are totality.
Oh, totality.
And the blue one, is it blue with totality or the red ones? And the red one's partial.
The blues are totals and the reds are partials. Yeah.
Blues are totals and partials. So they're just
the ones
look how they travel. It's just crazy, isn't it?
The ones that are really, really wacky looking, when you do wrap them on the ball, they basically make a dot. They make a circle. If you wrap it, you have to kind of think that I got to wrap Antarctica onto the ball, so it actually brings that shadow with it. It makes kind of a looping circle, like a dot almost, like a complete circle. But that still means that you'd have to have the moon underneath the globe model, and with the sun completely directly above 90 degrees to Antarctica itself. Like, so the sun would have to be directly below the South Pole and the moon directly below the South Pole to cast a shadow on the South Pole. Period. Like there's no other way to do it. It's very strange.
I don't know. I could look at that for a long time.
Yeah.
Yeah.
Not so much the ones that are not so much the ones that are partials, but the ones that are in particular the totality. You have to have a perfect alignment to get totality, right? The light has to be 90 degrees to the object to get totality, and those are the ones to really focus on.
See, really, this is I think something to be concentrating on. Just like you can't get this on a ball. It's not happening. Doesn't work, does it?
No chance.
Not even the most simplest of bloody, eclipses
When you
are
think
working.
about it, the ball can't work with all that water and land and spinning. It can't.
That's what I said
That
in my
can't work
last
anything.
video. You got an ocean of water sat there, and yet a butterfly can just take off. Gravity, yeah.
No, it's silly.
Gravity. No,
I mean,
don't
how
think
does a
so.
whale jump out of the water then? I know it goes back in the water, but how would it be able to jump out of the water and go back in?
It's just like that massive weight.
Exactly.
it
And not
can't
only
be
that,
held down.
when you dive in a swimming pool, why isn't gravity pulling you down to the centre of mass? You know what I mean? It should be dragging you down to the bottom of the pool, shouldn't it, really, if you think about it?
We live in such an amazing place.
Yeah.
It's just density. You're heavier than air. That's why you're below the air.
Exactly.
Above the air, there's gases, isn't there? You can look in my time-lapse videos. You can clearly see there's layers in that sky. There's like we've got the air down here, and then above it, there's like a thinner air or whatever it is. I don't know. I'm not gonna know.
Yeah. Interesting. In my moon race observations, from the UK, as the moon gets southern declination towards the Tropic of Capricorn, you can actually see the radius of the moon get smaller. Do you know what I mean? You can actually see it because obviously I shot mine when it was on Tropic of Capricorn, the equator, over a 2-week period, and the moon, if you overlay them on each other, the moon on the Tropic of Cancer is a lot bigger than the moon on the equator, which is bigger than the actual one, which was smallest on the Tropic of Capricorn. So it does actually diminish, even though
It's changing a lot, though, Dave. I've noticed there's a lot of difference in the size of the moon, but I don't know if that's atmosphere. If I don't know what it is.
obviously when it's close, when it's on the horizon, east and west, it's a lot bigger, obviously due to atmospheric lensing, but we're not getting that lensing effect when it's furthest south, which you think you'd get more because you're seeing through more layers of atmosphere. So it's quite a strange one.
Yeah, but you're not seeing through more because it's not moving as far as you're thinking. Do you get me? It's only dropping down in your sky. There's nothing. That's what I say. The sky is a rainbow. You're not looking at a rock. You're looking at a rainbow.
It kind of makes sense.
Like
Like if you,
I've always said it's been like a type of projection. Anyway, that's what I've said that for quite a long time. I don't know if you're on the similar thoughts to that.
Yeah, so you're not that's what I'm saying. You're not looking at anything of substance. It's not moving down to the bottom of the earth or whatever. It's like
it's just due to perspective.
Yeah, it's just moving down in your sky. That's all it's doing. It's your moving.
yeah.
Yeah.
When the moon rises to the east in the morning or whatever, you'd be technically looking through, what would it be, about 6,000 miles potentially of atmosphere that magnifies it. But when it goes south, because it only travels within the tropics, you're only still looking through, it'd be about 2,000 miles compared to 6,000. So I could see where the magnification would change.
Yeah, exactly.
Yeah. Plus, you get the flip flop at the equator too, right? It's and magnetism is going to play a role in that as well. So
the moon doesn't get quite high as the sun either as well. If you compare them, there's quite a significant difference in obviously when the sun's high on the Tropic of Cancer, you can see the actual angles a lot. Your viewing angles a lot more. I think what they did in the heliocentric model, instead of that 5 degrees inclination, it basically falls 5 degrees short of the tropics either end. That's where they swapped it around, kind of thing. You know what I mean?
Yeah.
So the moon never gets quiet as far.
They play so many games with that globe, like it's unreal.
Yeah, that's why they said a mini moon when it's an apogee, and obviously from us they call it a mini moon, but. You know what I mean? Is it a really mini moon? You know what I mean? Or a super moon when it's the other side? Is it a super moon?
Yeah.
Who knows? I was out there all night for that super moon film. Then.
Yeah, I got it. I got it in the end.
I got so much footage that night, and I've seen it look as big as that. Like it looks bigger to me when it's rising and setting.
Yeah, and not only that, it looked bigger the month after actually.
Yeah, I thought the same thing. They're not right about everything as we're showing,
Yeah, and just from my days, when I was doing the surveying on sites and so forth, the other thing that plays a major role in what you see in the air is the temperature and the humidity. So if you're north and it's really cold, then you don't get the magnification effect as if you would, like if you're in the tropics and it's really humid. The more water that's in the air, the bigger the image would appear to you, right? So temperature and humidity plays a big role in that too, as well as your location and how much you're looking through, right?
Yeah, exactly.
Yeah. Magic.
Yeah. Magic sky.
Yeah.
Well, when you told us the other day that basically with your perspective, the stars come out of the ground and go round, you explained that a bit today. I know it was kind of in that video because you were just like...
Where you're seeing that line, like a rainbow, that's how I keep saying. If you're on the ground, you only see the top half of the rainbow. If you lift yourself off the ground, you bring the bottom half out of the ground. It's always there, you just can't see it when you're stood on the ground.
Exactly. Yeah. You see half the rainbow.
What you're seeing in them videos that we're making is you're just seeing the rainbow because you're stood on the ground, and that's what you're seeing with the moon. I'm not sure if you travel up, you'll bring it out like you can a rainbow, but if you move around, it definitely moves like a rainbow.
I think it'd be really interesting to set up like a drone with a 360 camera on it, one facing down, one facing up, and put it up in the air and leave it up there for a full 24-hour cycle.
Definitely.
Right.
Different altitudes as well, Chris,
Yeah. Well, yeah, take it up as high as you can, get up there, 20, 30,000 feet as far as you can get it.
Yeah, but start at like 5,000 and then 10,000 and then 15. Just keep going until it just falls to the ground. Get as much as you can out of it before you kill it straight away.
Yeah, exactly. Yeah.
How much footage can you get from these 360 cameras? How much can you get in one recording?
I'll leave it running all week.
What is it? Is it constantly connected to mains? Is it? And
yeah, I've got mine. Mine's in a little plastic case, I can send you pictures in that, Dave, if you want. I just drilled a hole in the side. I plugged it in, and then I put electric tape over the hole so no water goes in the case at all. And then it's on a pole attached to my chimney on my roof.
Cool.
And I've got mine hooked up with an old laptop for a Wi-Fi connection, so I can just see what it's doing, and
Is there any way we can show one of your videos, then, Stan, or a couple of your videos with this camera?
No actual footage of the camera, just footage from the camera, and I reckon if you play it,
What I mean, from the camera.
It might crash your Hangout because it's a 4K. There is a lot of video in that video, if you get me.
What do you store the video onto? Because you only get 7 minutes in 4K on my camera.
Well,
Just store it straight.
I'm doing time lapse.
Oh, right, got you. Right, yeah.
And well, it will take a 4K picture, but it's not. I'm not recording in that 4K at the set because I'm only interested in where it is, like location at the moment.
20 megapixels or something like that.
Yeah, I'm unsure. I've got a 32 gig card in there, and that lasts me a week.
Cool.
If you've got a decent location where you can get to the camera, you can just pull the card out, just put it onto your PC, upload it to YouTube. You ain't got to do any special thing with it. You can just put the raw file on, and from that we can then create the images to show you what you're seeing in VR.
I've got a design I did there in the model for that exact idea too, was to have the 4 balloons and a drone on the bottom, and then have a rocket on there too. If you want to launch a small rocket, once you get to 100,000 feet, you could launch a rocket, take another couple 100,000 feet. To see what.
I reckon we launch a firework to celebrate the death of the ball.
Yeah. I pulled it up on the screen there. You can see the model if you want, but
yeah, I see it, and that is cool. Like, I think we should definitely we need like 3 of them.
Yeah,
we need to make that happen. There must be someone watching now that wants to know and has got the money to just say, there you go.
Yeah, I got some guys interested in actually supporting the project like that. One fella's into the drones. He's got a couple extra drones. So there's more than just me looking at it, but we need some good data and some good.
What would you do? Get the balloons up to about 100,000 feet, then obviously when they equalise, kick the drone in, or.
Well, what you do is you take the whole thing up to 100,000 feet, and then have an altimeter, like in this little top part here has got the gear in it, right, for altimeter, pressure, temperature, and that type of stuff. And once you just have a trigger when you hit 100,000 feet, then it just lights the rocket that launches itself, and it has a camera on it too, so you can see it go up, and it has a 360 camera on it. And then the balloons have pop valves that just kind of slowly depressurize, brings it back down to 5,000 feet, so that you can now fly it back home. Just it'll automatically return home after it gets to 5,000 feet. The waypoint programmed, and it just flies back home.
Can we leave the helium in them balloons though? So it just, like, when you get up there, you just blow some helium out to balance it.
Yes, that's it. Yeah, it has the balancing valves in it. So you take it up to the 100,000 foot mark and then balance them so it stays there, right? And then when you want to come down, you just release the helium and bring it back down slow.
Yeah, a little bit more out.
Because that's the problem with the balloon launches, is they go up and then the balloons pop, and then you got to search for the thing for 3 days to find it, right? Well, this one, it goes up, it stays as long as you want, right? And then it comes down slow and then flies home. So you lose part of the rocket, but.
So you need that as well with a gyro, so it stays one spot, so you go up there and then the drone kicks in as well and like keeps it.
You can use a gimbal.
Yeah.
You could use a gimbal, couldn't you?
Yeah. Well, you'd use some sort of board.
Yeah, I got four gyros in the corners, right, and then that keeps it stable and locked into position. And then you just turn them off when it comes back down, and then it flies home.
Yeah, we need to build that, and then we need to make 3 of them.
Yeah, that'd be cool, right?
Yeah, that would. Maybe we just need an army of them. That would be cool. We could get so much data with that, and like you could have the ground see with the 360, and you could have that with 360, and the data collecting would be phenomenal.
I'm sure if you tried to launch it, you'd have somebody knocking at your door as soon as you tried to launch it, I'm sure, but it's worth a shot. I don't know.
Do you want me to read you out my letter, what I wrote to the UK Space Agency?
Yeah.
Go on, Dave.
Yeah, I've had a reply back as well.
Have you?
So,
Classic.
Yeah.
I'll mute a minute.
So it was titled "A Concerned Taxpayer Regarding Fake in Space." So I put, "I'm writing this letter of concern in regards to how much the annual budget is for the UK Space Agency. I currently work as a line manager for the NHS, and over the past few years have seen restructures and fellow co-workers losing their jobs. We are tasked with saving the NHS millions of pounds year after year. I have recently been doing research into space travel and all the space agencies relating to this, NASA, ESA, JAXA, Roscosmos, to name a few. Also, the so-called private sector of space travel, namely Virgin Galactic and SpaceX. On close inspection, it is pretty clear to me that no one has ever been to space. I've watched hundreds of rocket launches from Apollo to the recent SpaceX launch. Firstly, the rocket trajectory is all wrong. All amateur rockets go straight up and reach the stratosphere in about 1 minute. All official rocket launches start arcing way too soon to even get anywhere near celestial space. This is more apparent when watching the old space shuttle launches viewed from a Boeing at approximately 20,000 feet. Secondly, there are no images of Earth or satellites in space. When I searched for these images, you would have thought in 2017 there would be thousands of images, and all we get are composites of Earth and CGI images of satellites. It's an absolute joke. On further investigation, it's clear that all images of Earth are actually created by computer software. Is the creative designer responsible for creating all NASA's images of Earth? Finally, after watching hours of live footage and interviews from the International Space Station, it's clear we are being deceived on a major level. All the astronauts are being filmed in a studio. In fact, one astronaut actually referred to being on Earth by mistake. I have seen harnesses slip, augmented virtual reality glitches, video overlays, static backgrounds, parabolic flights made to simulate zero-G. It's all fake to make everyone believe that space travel is possible. Growing number of people, including myself, waking up to this nonsense, and we are doing our utmost to expose the lies and deception. I've included a link to a video I created exposing this deception. Maybe you could watch it and explain to me why there are so many inconsistencies related to footage recorded on board the International Space Station. And then I've included the link. It says, through the Information Act, I would like to request a complete breakdown of the budget related to the UK Space Agency and what my hard-earned taxes are actually contributing to. I have seen absolutely nothing. Kind regards, Dave M. That's it.
Yay! Well done, Dave. That was a really good letter.
Yeah, and if I go to my inbox, I don't know if you'll be able to see this, but if you go onto my where is it? I'll find it in a sec.
It's always when you want it. You can never find it quick enough, can you?
Yeah, I've got it. I think it's the yeah, I've got it here. It's at the bottom of the actual message. So I don't know if you'll be able to see this, but you might be able to see a little bit of it.
Yeah. Okay. Yeah.
See, I've got a letter back from the Space Agency. Yeah. So it says, "Dear Mr. Marsh, thank you for your email on 31st of July 2017 requesting the following information: a complete breakdown of the budget related to the UK Space Agency. I am treating your correspondence as a request for information under the Freedom of Information Act 2000. You should expect to receive a further reply from UKSA within 20 working days from the day when your request was originally received by the agency. If you have any queries about this request, do not hesitate to contact me. Please quote the reference number above in any future communications. So now basically I'm just going to wait back for the reply, and because the budget of £388 million a year is just absolutely ridiculous. And not only that, they've also given another 100 million on the back of that to some university to research more into space, which is complete bollocks. You know what I mean? This is our tax money, yeah. And what have they got to show for it? Tim Peake went to space in 2015 or 2016, wherever it was. So they're not funding him no more. So what are we actually paying for? We don't launch any rockets, yeah. You know what I mean? The satellites are already up there. We don't need to launch any more. There's about
It's to get Tim up there. It's to get Tim up there.
Well, get him down there because he's going. He won't be going up. He'll be going down. He'll be splashing down to the ISS.
Yeah.
So, but interestingly, on the ISS, when you look back through the years, go right back to Sputnik when it was launched, they knew when it was passing over, and then you could go out and you could observe it over your head. So you'd probably see a white light like you see now with the ISS. Then as the years moved on, that you got to like a Skylab. So when that was going over, then they say, oh, that's going over. Then you see the same probably white light they saw when they saw the Sputnik. Now we're onto the ISS, and with all the tracking software, you'll probably see the same light. It's probably some kind of, I don't know, shooting star or some kind of comet or some kind of natural phenomena caught in the electromagnetic field up there. You know what I mean? But they're just using that as an excuse to say, yes, we've got space stations up there, because clearly it's not a space station.
No, that's
My
right.
thoughts on it anyway.
Just going to say, all that money that they waste, yeah, we only need about 10 grand a drone, you know.
Exactly. Interestingly, you know, Obamacare, the actual cost of Obamacare from like beginning to end, yeah, it would have been cheaper to give every person in America over the age of 18 $1 million each. That's how much it's cost. You know what I mean? That just shows you what they're doing. It's just ridiculous. Some of the money they're just wasting. Yeah, you could have just given every citizen in America $1 million each, and it probably saved them millions.
But they could have given us some money for some drones and everything else for us to do it ourselves.
How about just don't tax us in the first place, and then we'll be all right.
Yeah. Exactly.
Anyway, do they? Because we've got the death certificate, and they're making loads of money out of that.
Yeah, it's not just a tax on your wages. You get taxed on everything, don't you? You know what I mean? It's everything. Like,
pay the tax, you put it in your savings account, you have to get taxed again before you can draw it.
Guess what, Karen? When we went to that meetup a few weeks ago, we got fined £25 for parking van.
Did you? Oh,
yeah,
no.
It was £50 fine, but if you paid it within 2 weeks, it was 25 quid. So it was quite an expensive day out, really.
Oh no.
Yeah, we went back as well twice to put a new ticket on the van, like, and we thought we'd leave it for the last half an hour because we was in the pub and that, and we thought, sorry, I'm sure there's going to be nobody around at 7 o'clock at night, but there it were, slapped on the front of the van windscreen.
They were waiting for you, though.
Yeah, well, that's what they do. That's what the tasked to do, aren't they? To collect as much revenue as possible. Do you know what I mean? You go to Matlock Bath on a Saturday or Sunday afternoon, yeah, and what you'll see about 15 coppers walking up and down there, yeah, taking all registrations and motorbikes to see if they do come back within an hour, then they're going to slap a fine on them. You know what I mean? They just take advantage of certain situations. There's probably somebody being robbed and burgled and what have you up the road in Nottingham, but they'd rather put all the resources there because they know they're going to get more money out of it.
Maybe if you don't get, I was going to say maybe if you don't get a sufficient reply from the UK Space Agency, then you reply back to them and just say, based on the justification that you cannot provide me with the information requested, I'm no longer paying taxes because you haven't satisfactorily, looked after my concerns, right?
You pay taxes anyway, though. You think of your fuel bill.
In the UK, your taxes automatic. If you've got like a job, like a normal job, not a self-employed job, you automatically get all the stoppages taken out before you get paid, so you don't have a choice.
Oh, is that right?
Yeah. It's already taken out your wages. But when I get paid monthly, boom, it's all out. Yeah.
Yeah, I think in Canada, I think you can still at least have the option whether or not it's taken automatically or you pay it yourself. I think there is that option when you sign up for your deductions. But yeah,
It's just tax, bill, tax, bill.
That was a good letter,
Yes.
though, Dave. It'd be interesting to see what
It
you
was.
think about that.
I want to see what they say. Yeah.
Yeah.
Yeah, but they will. They'll send him so much information. It'll probably take him about 6 years to go through it.
They'll send you a PDF spreadsheet, which only like 3 people in the world could actually understand. That's what they'll do. Trust me, there'll be that
Oh,
much gobbledy in it. Yeah, all these numbers, figures, and stuff like that. And yeah, there's nothing you could actually. They've probably got their own watchdogs who are on the same team, kind of thing. You know what I mean? No independent watchdogs for them, like, because surely they can't justify that much money. And not only that. There's a European Space Agency as well, because their budget is 5.1 billion euros a year. You know what I mean? And then NASA's got the 19 billion budget, which is more than every single budget of every single space agency what's ever been around, like, kind of thing. And did you watch the
things? Don't they? They're using it for wars and all there's loads of things that we don't know about.
Yeah, they've. You know what I mean? They've got to fund all the wars and that, aren't they? Like I said, there's people starving in countries and what have you.
Haven't they? What about all the hoax things that happen? They've got to fake all those. They take money.
Exactly.
I dread to think how much it's costing to paint our sky with all the crap they painted with.
Bloody hell! You know what? Even you get up and you see a little bit of sunlight coming out, you think, oh, it's going to be a nice day today. You go outside and it's just absolutely plastered. You know what I mean? It's like I say, you can never get a decent shot of the moon. You know what I mean? It's very rare. Even tonight, like, you see the odd chemtrail drifting in front of it, kind of thing.
I've had the perfect, like, you know, the moon with the plane and then the trail behind it going through my moon shot before when I've been out there.
Yeah, I've got that as well.
It's like, nice one, lads. Cheers. You know.
Yeah, I've got a couple of them as well.
Yeah. So that's costing some money, man.
I've taken. I can't believe how many stripes there are up there. How much chemtrailing they're doing.
It's just worldwide as well, isn't it?
Yeah,
it's circulation worldwide now.
It's not just here; it's everywhere. You know what I mean? It's
South Africa, Cape Town. Cosmic Surfer says he doesn't have them. He said he's never seen one. I was like, really? And he was like, never seen one. But then I look at how many planes, and there was like 3 planes in Cape Town. So they all fly away from him. You know, they don't fly over him.
Yeah.
So.
Yeah, that's strange, isn't it? Yeah, because they'll all fly in a V shape, won't they? Like fly up towards the north, kind of thing.
Yeah, you always see them in pairs.
North.
The annoying thing is they let you have the cameras, and then they spend the rest of the time trying to cover everything up.
Yeah, but interestingly, you would have thought Nikon would have brought a new camera out by now, because they haven't. How long's the P900 been out now? It must be 2 years, surely, if not more. Why aren't they updated like they do every other camera every year?
Scared, been told off, mate.
Because really, they could put 100 times zoom on that with 20 megapixel and 4K video. You know what I mean? There's no stopping them doing that. It's possible. I mean, the B700 I've got is 20.3 megapixel and shoots in ultra HD. So basically, it'd just be that combined with a 100 times optical zoom.
The chip in my phone's better than the chip in my camera and the P900. Like my Samsung S7, it takes a better photo than my P900, but it just hasn't got the zoom. Because we were sat there thinking, how can we pull that apart and put it into the camera, you know?
Yeah, it's they didn't put a very good thing on it, did they? Sensor on the actual P900. It is actually updated a little bit on the B700. Not a lot more, but it is
just
a little bit better.
Zoomer. That's all it is.
Yeah, it's just for zooming.
You want to go out and film the moon or film some chemtrails, it's the perfect bit of kit. But if you want a crisp, clear photo, then it's junk. Forget it. Or star trails, it ain't very good for star trails. You have to trick the camera. You know, you have to get a torch and trick it.
Yeah. You have to even find Boris, you have to trick it then, you know, to get your because with it being such a dim star, it's a nightmare to get hold of. Like, you mess about with the compensation, exposure. I mean, turn it right up to the max, like, and say, then just flip the camera up and down a little bit so you can try and pick it up. But it took me about 10 minutes just to get it in the actual frame line.
Yeah, that's what I say. They're not easy to work, a P900. Whereas your 360 for filming the moon is a piece of cake. You put it down, you push record, and you walk away, and you leave it for a week. You know, it's that simple.
Cool.
There's
yeah,
no
that's some
work.
good stuff you're doing now.
Yeah, you should really get one though, Dave. They're so cheap.
Yeah, I like to say, I'll have a look around, like, because that would be brilliant for what I'm doing when I do my third experiment, like. So I'll be doing that in September. Well, hopefully, weather depending. You know, these days it's.
Yeah, no, mate. I've had 8 days. Today was the first blue sky day, and even that cloud goes by the end of the day.
Yeah, it's rubbish. Like I said, I'm sure when I first got my camera, the skies are pretty good because I was shooting stuff all the time. Like,
it was 2015 they started hammering it.
Last couple of years, it's got really bad.
Yeah, 2015 was the last sort of decent bit of sky we had.
Yeah, it's like I got my P610 in 2015, I think it was November 2015. So it would have been around then. That was a good camera, that P610. I picked it up for 215 quid in Curry's. It was a right bargain, that. It's basically a P900 but with a 60 times zoom.
And a better chip.
Yeah, I don't know if I think it was a little bit updated from that. Yeah, because I think it's a P600 what's got the same chip as the P900, isn't it?
Yeah.
Yeah.
Dave,
and the actual. Yeah, go on, pal.
I was going to ask you a question. It's just to go back to your letter there briefly. Have you seen the Ascension Island?
I've heard of it.
Did you see the little presentation that I went through from the pictures from that island on?
No, I didn't, mate. No.
No. Right on. You guys finish your chat there, and then I can show you the pictures, and I'll bring up some.
Yeah, go on, doing that, mate. I'm only going to be on for another few minutes, mate, because I want to get to bed. Yeah, go for it.
Yeah, it's getting late, and I need to get to bed.
Right,
got to be a slave tomorrow.
I got them sharing there. I got them sharing there now, so maybe you can see them.
Yeah, I'll just put it on to present. Okay.
So you can go on Google Earth and even scout around a little bit more if you want. But
there you go.
Are we up and running?
It's there. I've presented you now, Chris.
Right. So check this out, Dave, Stan, and everybody else. Yeah. This is a little island off the coast of, it's between South America and Africa. It's 8 kilometers square. Little tiny island called Ascension Island. So there's Moon Base 1, Topless Beach, with the radar station for tracking. So when they take off from Florida or anywhere else, they go here for a little vacation. There's the European Space Agency tracking station. You'll find some of these names are really ironic, just kind of like mocking, like in your face. Here's the desert lunaire, which is the moon desert, right? And you can still see the buggy tracks in the sand. It's a nice backdrop like you've seen from old.
Yeah, I've seen Buzz Aldrin stood in front of that picture there. I'm sure I have.
Yeah. Yeah, I'm sure you have, yeah.
Yeah, same double mountain.
Yeah, there's the antenna field. This is the Devil's Riding School. So it's actually a crater that was formed by lightning, but it's still a crater. It's a Devil's Riding School where you ride the devil. Snob Hill. This one's pretty obvious too. It's the runway. The name of the actual name of the runway, when you look at it from Google Earth, it's about 4 kilometer runway, full for B2 heavies or B1 heavies, right? It'll take a heavy. It's they call it runway 13. And the airfield itself is called Wide Awake Airfield. So it's like wide awake, right? Just mocking people that are asleep, right? Here we are. Look at us.
Unbelievable, isn't it, really?
Yeah. And this is the beach. They've named it Marsh Bay. It's actually Marsh Bay.
Yeah,
Here's the piece to resist.
A bit of a red tint on that normally, but camera facing the other way, a bit of red tint.
Yeah, you can go to the island and actually go into the first person view on the beach and look around. It's like, wow, this looks just like the Mars rover, right? Exactly.
Can you travel to that island, or is it off limits?
It's pretty much on the it's not entirely off limits, but the red tape is so insurmountable. It takes you like 28 days of red tape, and you got to go through the British UAF and clearances and training, and and the cost is through the roof too. I can't remember what a one-way ticket was, like £3,000 or £4,000. So I mean, you're looking at 12 grand to get there and back, right? So nobody's going to do it, right? They just make it impossible. And here's the final kicker, right? They built a monument there out of stone that's a replica of the lunar lander with the 2 pairs. Yeah, there's a lunar module with the 2 pairs of sneakers for the 2 guys that walked with Buzz's sneakers, right?
Cool.
Yeah. So you know where some of the money's going.
That's Mars now. That's Mars as well, isn't it?
Yeah. There's other stuff there too. There's a full accommodations with swimming pools and a golf course where you play from crater to crater, right? So you play from 18 crater golf rather than 18 greens to 18 craters, right? Yeah.
Brilliant.
So, brilliant.
That's cool.
Yeah, exactly.
Right, guys, I'm going to shoot off.
Yeah, maybe throw some of that in your next letter and ask them what all this is. Yeah. How much does this cost?
Yeah.
It's time that we've been going now for 9:30, was it 10:30, 11:30, 12:30? We've been going for 4 odd hours, guys, so we're probably going to end the hangout now. Do you want to say anything before you go, Dave?
Yeah, don't forget to join my group, Flatline, on Facebook. Ever growing.
Yeah, I don't do Facebook, Dave, or I would, mate.
Oh, don't you do it at all, do you?
No, I don't do any of it.
Well, that's a shame. Yeah, I've got some good stuff on Facebook. I don't put everything on YouTube. I put quite a lot of it on just on Facebook, like on my group or just on my page. But if you get a chance to watch my ISS Smoke and Mirrors Redux, watch it because it's quite a funny video. And also I've got one called The Moon Job. Disprove gravity by time-lapsing the moon in front of a glass of water, which is a bit of a tongue-in-cheek video too. So go and check them out.
Well, you have to send us some links, add me on Hangouts or something. You have to add me somewhere, Skype somewhere. Somewhere.
Yeah, what's your YouTube channel?
Stan Smith.
I'll look it over. It's bound to be. If I go on to Cosmic Surfer, it's bound to be on.
Yeah. I'm on his feature channel.
Stan Smith, Flat Earth. You'll find him easy.
Yeah, cool.
Yeah, Flat Earth. Stan Smith.
If you put Dave Marsh Flat Earth in, it's the top one anyway. So.
Yeah.
We're going to end this hangout in a moment, but just a couple of words from Stan. Thank you for coming on, Stan. Thank you for coming on, Dave, by the way. Well, thank you, Chris. Thank you, Series. Series has been very quiet today. But just any final words, Stan?
No, just cheers for having me on. Anyone out there going to get a 360, get in contact with me if you need help or anything. I'd be willing to help you all I can.
In the hangout anyway. On the hangout, so if they can get to you by the hangout.
Oh, they can drop me a message on my YouTube or just comment on a video. Just use your initiative.
Anyway, we're going to have a quick group hug. We always have a group hug when we go. I don't know if Stan wants to show his face, but
yeah,
no, I'm all covered up.
Read the back.
I've got a dressing gown on. Look, guys, I'm in my dressing gown.
Research plan.
Come on for everybody. Thank you for listening in. I think it's been a great evening of explanations, and the eclipse doesn't work on their own globe. Is that right, guys? The eclipse doesn't work on their own globe.
Correct.
That's right.
Right. Thanks a lot.
Tell
So
it.
very much.
Series.
Thank you for everybody in the chat room. We'll be back tomorrow.
Take care.
Good
Right.
night.